Right. Good afternoon. Good afternoon, everyone. Welcome to the class. So, yesterday we have discussed logic gates, universal logic gates, then implementation of logic function using gates. Then we introduced propagation delay. So, what is exactly propagation delay? Why do we get propagation delay in our logic gate or logic circuit? How to analyze logic circuits when you are including propagation delay effects also? Right? A simple thing is drawing functional waveform, observing input variations with respect to time. When input changes or variations are provided with respect to time, and with respect to these input changes, we are writing functional output waveform. Once observing functional output waveform, shifting this functional output waveform by propagation delay or a positive delay or a positive shift or just moving right side, we get the waveform which you are expecting, including propagation delay effects. That's what we have discussed about propagation delay. Let us see how many of you have solved these questions correctly. I told you, I suggested you to solve these questions. Read the first question. The 2's complement numbers having sign bits x and y are added, and the sign bit of the result is z. Then the then the occurrence of overflow is indicated by the Boolean expression or Boolean function. Question is the 2's complement numbers having sign bits x and y are added, and the sign bit of the result is z. Then the occurrence of overflow is indicated by the Boolean function given. So what is given here is we are adding two numbers which are in 2's complement representation. X and y are sign bits of numbers we are adding. When you're adding these two, result sign bit we are getting is z. Using these three variables, what is the Boolean expression for overflow? What is overflow first of all? What we discussed about overflow? If number of bits used is not sufficient to represent the result or to hold the result, then we say overflow is occurring. Once again, if number of bits used is not sufficient to hold the result or to represent the result, then we say overflow is occurring. And how to analyze this? Very simple concept, but looks like very complex. Very easy way we can answer this question. Let us see what is that. First of all, if you are observing what is the range of decimal integers can be represented using 4 bits in 2's complement representation. The range of decimal integers can be represented using 4 bits in 2's complement representation. In 2's complement representation. It is -8 to +7. If you remember the range we have discussed, it is -8 to +7. Using 4 bits, the range is -8 to +7. In this range, if you're adding two numbers, if the result is also within the range -8 to +7, overflow is not occurring. If result is out of range, is nothing but less than -8, greater than +7, there will be overflow. It is not always 4 bits. To understand the concept, I am using 4-bit representation. When I am using 4 bits, the range of decimal integers is -8 to +7. In this range, if I'm adding two numbers, if result is within the range -8 to +7, overflow is not occurring. If result is out of range, then there is an overflow. Right? Now, a simple way we can understand this, just focus on this. 4 bits range is what? -8 to +7. In this range, we are adding two numbers. The sign bits of two numbers considered as X and Y. Sign bit of result is Z. See, XY can be 0, 0, 0, 1, 1, 0, 1, 1. XY 0, 0 is indicating adding two positive numbers. XY 0, 1 is indicating adding one positive, one negative. XY 1, 0 is indicating one negative, one positive. XY 1, 1 is indicating two negative numbers. XY 1, 1 is indicating two negative numbers. One by one. XY 0, 0, two positive numbers. XY 0, 1, positive, negative. XY 1, 0, negative, positive. XY 1, 1, two negative numbers. And what about the result? Sign bit of result is Z. Z equal to 0, result is positive. Z equals to 1, result is negative. Z equal to 0, result is positive. Z equals to 1, result is negative. Ganeshwari, you might be having problem with your system or device. Please check it. From my side, everything is fine. Because everyone is able to see what I'm writing as well as my video also. Please log out and log in. Anyone else is facing any problem with respect to audio and video? Many are able to, right? I haven't written anything. Sitaram. Right? For everyone, it is fine. For few means there may be problem at your end. Please check it. If you face any problem, log out and log in. Why chat box is additionally added today? Where is the chat box separately? Okay. I didn't write anything. Lastly, wait. Just I'm talking about given information. I will write. Wait. Okay. So what we are thinking is considering 4 bits, I'm observing the possibilities. When I'm using 4 bits, the range is -8 to +7. The range is -8 to +7. In this, I can consider two numbers to add. If the result is within the range -8 to +7, overflow is not occurring. If the result is out of range, overflow is occurring. Right? The thing we are considering here, x, y are sign bits of numbers we are adding. Z is sign bit of result. XY00 is indicating adding two positive numbers. XY01 is indicating adding one positive, one negative. XY10 is indicating adding one negative, one positive. XY11 is indicating adding two negative numbers. Z equal to 0 is indicating result is positive. Z equals to 1 is indicating result is negative. With these conditions, we need to verify where there is a possibility for getting overflow. Let us see one by one. Adding two opposite sign numbers. What is that here? Positive, negative, negative, positive. Adding two opposite sign numbers. Will there be overflow or not? Let us verify. For example, -8 plus 1. When you're adding -8 plus 1, result will be -7. It is within the range. -8 plus 2, -6 within the range. -1 plus 7, plus 6 within the range. First of all, where is the possibility of getting a bigger number when you're adding two opposite sign number? When you're adding two opposite sign number, one will be subtracted from another one. Sign of the result is depending on whichever is having bigger magnitude, either positive number or negative number. Result may be positive or negative, depending on magnitude of positive number or negative number. So one will be subtracted from another one. Result sign bit, result sign is depending on which number is having more magnitude. Once again, when you're adding two opposite sign number, impossible to get overflow because it will be within the range only. Check with the possibilities. When you're adding two opposite sign number, what is that here? One positive, one negative, or one negative, one positive. If I consider, result may be positive, result may be negative, but result is within the range. That means XY01 or 10 is indicating adding two opposite sign number. Z equal to 0 or 1. That means result may be positive or negative. Result is within the range. Result is within the range. Once again, adding two opposite sign numbers is confirming that there won't be any overflow. Result may be positive or negative. Z may be 0 or 1. Impossible to get overflow. Coming to two positive numbers. When you are adding two positive numbers, that means XY00 plus 3 plus 4, result is plus 7. It is within the range. Overflow is not occurring. Plus 4 plus 5, result is plus 9. It is out of range of 4 bits. Observe correctly. Analysis with respect to 4 bits when I'm adding two positive numbers, which is indicating XY00. Right. Now, example, plus 3 plus 4, result is plus 7, still within the range. Plus 4 plus 5, result is plus 9, it is out of range. That means when you're adding two positive numbers, there may be overflow, but not always. When we are adding two positive numbers, there may be overflow, but not always. Now, next, coming to two negative numbers. XY11, two negative numbers. XY11, two negative numbers. When we are adding two negative numbers, XY11 is indicating adding two negative numbers. Let us see what happens. -3 minus 5, if I'm adding, -8. -3 minus 5, result is -8. Is it within the range or out of range? Within the range, because range of 4 bits is -8 to +7. When you're getting result is -8, within the range. Example, -3 minus 8 if I consider, result is -8. Right? -3 minus 5 if I consider, to add, result is -8, within the range. Similarly, if I consider -4 minus 5, result is -9. Now it is out of range. Whatever I said in words, let me summarize. Adding two opposite signed numbers, that means XY01 or 10. Z may be 0 or 1. Result may be positive or negative. Result is within the range. Overflow is not occurring. Another thing, adding two positive numbers, that means xy 0, 0. There may be overflow, but not always. Again, xy 1, 1, adding two negative numbers. Result may be within the range, result may be out of range. That means in some condition there will be overflow, in some other condition there won't be overflow. Simple thing is when you're adding two positive numbers, there may be overflow. Adding two negative numbers also, there may be overflow. Adding two opposite sign numbers, result may be positive or negative, there won't be overflow. That's it. That is sufficient to answer this question. So let me consider x, y, z. Let me say overflow function f. F equals to 1, overflow is occurring. F equal to 0, overflow is not occurring. Let me consider f equal to 0, overflow is not occurring. F equals to 1, overflow is occurring. That convention I am using. So now x, y, z variables we are considering. Possibilities if you write 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1, 1, 1, 1. Right? These are possible combinations of x, y, z. Now, as we discussed already, for all these four conditions, what you are observing, x, y, 0, 1 or 1, 0. For all these four conditions, x, y, 0, 1 or 1, 0. That means adding positive, negative or negative, positive, two opposite sign number, overflow never occur. So z may be 0 or 1, result may be positive or negative, overflow will not occur. F equal to 0, overflow is not occurring. xy 0, 1 or 1, 0, adding positive, negative, negative, positive, result may be positive or negative, result is within the range, overflow is not occurring. Coming to xy 0, 0 means adding two positive numbers. xy 0, 0, adding two positive numbers. Z equal to 0, result is positive. Z equals to 1, result is negative. In one case, there is overflow, it is out of range. One case, it is within the range, overflow is not occurring. When you are adding two positive numbers, every time there is no overflow. In some conditions, there is overflow. In some other condition, there won't be overflow. Now, let us see which one can be correct, which one can be overflow occurrence. xy 0, 0, adding two positive numbers. Z equal to 0, result is positive. Z equals to 1, result is negative. When you're adding two positive numbers, how can we get result is negative? When you're adding two positive numbers, how can you say result will be negative? Why it is giving negative result, which is wrong result? Because it cannot hold the result. Because it cannot hold the result. That means there is an overflow. Once again, adding two positive numbers, there may be overflow, but not always. In some condition, there will be overflow. In some other condition, there won't be overflow. Then, if you are observing this, xy 0, 0, adding two positive numbers, z equal to 0, result is positive, acceptable. Z equals to 1, result is negative. How can I accept result is negative when I am adding two positive numbers? Impossible. Why it is giving wrong result? Because of overflow. Because of overflow. xy 1, 1 is indicating adding two negative numbers. Z equal to 0, result is positive. Z equals to 1, result is negative. Once again, xy 1, 1 is indicating adding two negative numbers. Z equal to 0, result is positive. Z equals to 1, result is negative. xy 1, 1, adding two negative numbers. Z equal to 0, result is positive. Impossible. xy 1, 1, adding two negative numbers. Z equals to 1, result is negative. That means negative result is correct, acceptable, there won't be overflow. If it is showing that positive result, because of overflow, it is giving wrong result. Then overflow, here overflow not. All this based on basics of two's complement representations. We should know the ring, right? We should know where there is a possibility for getting wrong result. There is a, what is that overflow? Whatever the points we have discussed in representations, all those are useful in answering this question, previous question. Then what is that F expression? Here it is min term. What is it? X, Y, Z is 0, 0, 1. X bar, Y bar, Z. And 1, 1, 0, overflow is occurring. That means X, Y, Z bar. right? 0, 0, 1, overflow is occurring. 1, 1, 0, overflow is occurring. X bar, Y bar, Z, X plus X, Y, Z. After all this, what is this here? Simple thing. X, Y, 0, 0, adding positive number, Z equals to 1, wrong result, overflow is occurring. X, Y, 1, 1, adding two negative numbers, Z equal to 0, positive, again, because of overflow, it is giving wrong result. Adding two positive numbers to negative numbers, there can be overflow, but not always. When it is showing that wrong result, there will be overflow. When you're adding two opposite side numbers, impossible to get overflow. That's it. After all this is the summary. Very simple thing. But to understand these, all the concepts is important, whatever we have discussed. If anyone is having any questions with respect to this, I will help. Right. People are worrying about what is there on the board, what is there on the board. Yes, it is there now. This is the question. Anyone has any doubts with respect to previous question? Okay. The box is XY01 or 10. That is indicating adding one positive number, one negative number, or one negative number, one positive number. When you are adding opposite side number, overflow will not be occurring. That confirmed. Already we have discussed when you are adding to opposite side number, we are subtracting from another one. Where is the possibility for getting bigger number? Maybe more negative or more positive? Impossible. Because when you are adding two opposite side number, obviously one will be subtracted from another one. Result sign is decided by which number is having most magnitude, either positive number or negative number. If positive number is having most magnitude, result is positive. If negative number is having most magnitude, negative result. But impossible to get a overflow. The box. Someone was asking about box, right? Yes, some people are asking about Manikantha, right? I will write for overflows. Examples we can consider. So whatever we have considered, let me consider that one. Plus 3 plus 4, result is plus 7. Overflow is occurring or not occurring? No. Plus 4 plus 5, result is plus 9. Overflow is occurring. Correct. Minus 3 minus 5, result is minus 8. Overflow is occurring? No. Minus 4 minus 5, result is minus 9. Yes, overflow is occurring. Some people are asking about this also. Let me explain this. Because examples we have considered this. Yes, plus 3 using 4 bits. You must be in a position to represent numbers easily. Plus 3 using 4 bits, 0, 0, 1, 1 using 4 bits. Plus 4 using 4 bits, 0, 1, 0, 0, right? Plus 3 plus 4. Let me add these two. What we get here? 1, 1, 1, 0. Right? Then what is this? X. What is this? Y. What is this? Z. X equal to 0, Y equal to 0, Z equal to 0, overflow is not occurring. That's what we are saying, that F equal to 0, overflow is not occurring. To get more clarity, I am trying with examples. X equal to 0, sine bit of one number. Y equal to 0, sine bit of another number. Z equal to 0, sine bit of result. Then overflow is not occurring. Yes. Plus 4 plus 5 plus 9, overflow is occurring. Let me complete this. Plus 4 using 4 bits is 0, 1, 0, 0. Right? Practice this representation, sir. Plus 5 using 4 bits, 0, 1, 0, 1. Right? Let me add this. 1, 0, 1 plus 1 is 0, 1 is carry, 1 plus 0 plus 0 is 1. Then Let us decide which is x, which is y. Here it is x, it is y, it is z. X equal to 0, y equal to 0, z equals to 1. Overflow is occurring. X equal to 0, y equal to 0, z equals to 1. Overflow is occurring. Right? Minus 3 minus 5 is equals to minus 8. Will there be overflow? No. Let us see how to write minus 3 and minus 5. How to write minus 3 using 4 bits? 1, 1, 0, 1. Correct? 1, 1, 0, 1. Minus 8 plus 4 plus 1, it is minus 3. What about minus 5? 1, 0, 1, 1. Let us add these two. 1 plus 1 is 0, 1 is carry. 1 plus 1 is 0, 1 is carry. 1 plus 1 is 0, 1 is carry. 1 plus 1 plus 1, it is a 3. It is nothing but 1, 1. In 2's complement arithmetic, discarding the carry. Right? So what we are getting here? X, Y, Z. X equals to 1, Y equals to 1, Z equals to 1. Overflow is not occurring. X equals to 1, Y equals to 1, Z equals to 1. Overflow is not occurring. Next, minus 4 minus 5 is equals to minus 9. Minus 4, 1, 1, 0, 0. Minus 5, 1, 0, 1, 1. Add 1, 1, 1. 1 plus 1 is what? 1 plus 1 is what? 2, which is nothing but a 1, 0. 0 is a sum, 1 is carry. Discarding this carry. Then what we get here? X, Y, Z. X equals to 1, Y equals to 1, Z equal to 0. Overflow is occurring. X equals to 1, Y equals to 1, Z equal to 0. Overflow is occurring. These 4 cases we don't need to verify. Confirm. This box, 4 cases we don't need to verify. Shubham. In which conditions of X, Y, Z there will be overflow? That is a question. So read the question. The Boolean expression which indicates overflow. The occurrence of overflow is indicated by the Boolean function. So you need to set a function with x, y, z as variables. Read the question correctly. Manisha, the CRPQ is not separately for chapters. Only one file. In that chapter 1, chapter 2, we have. Just go through that. This is a question. This is answer. This is answer. Manikanta. Yes, if you are providing one more bit, result will be correct. With the bits we have used, there will be overflow. Ashoka. Yes. I think everything is fine with respect to this question. I'm moving to next question. If the input to the digital circuit in the figure consisting of a cascade of 20 XOR gates is X, then the output Y is equal to what we have here. We have 20 XOR gates in cascade connection. Akash, Read the question. Why are you getting doubt? That is the reason I said go through these questions before coming to the class. 2's complement numbers having sign bits x and y. That means if you are considering one number of n bits, so it is having sign bit is x. Another 2's complement number, two 2's complement numbers means we have 2's complement numbers. So to add, we are considering two numbers, two 2's complement numbers. Ashoka, sorry, Akash. Two 2's complement numbers means for adding, we need two numbers. That's what we are considering. Akash. I hope everyone is having question papers or classroom practice questions. Sometimes it may not be possible to display correctly here. Just go through that if it is not possible to display. Simple thing, what is there in this question? So here we have 20 XOR gates. If you are analyzing one or two, you can understand correctly. So first XOR gate, if you are observing, what we have here, 1 and X. What will be the output of X here? X bar. What is the output of a second XOR gate? X bar is one input, X is another input. X bar and X output is what? 1. After two XOR gates, output is 1. After two more gates, XOR gate output is 1. After even number of XOR gates, output will be 1. Will there be any doubt? No. Yes. It is a 1. In the same, if I say 25 XOR gates, then it will be X bar. When you have odd number of XOR gates, output of this cascade connection will be X bar. If it is even number of XOR gates, it can be 2, it can be 4, it can be 40, it can be 100. If it is even number of XOR gates in this cascade, it will be 1. If it is odd number of XOR gates, it will be X bar. In this connection, it is not generic with respect to odd and even. In this circuit, if it is cascaded, even number of XOR gates, output is 1. If it is odd number of XOR gates, it will be X bar. I will discuss this question because here it is used a word redundant. I haven't talked about redundant until that. Hold on. Question number 3, right? It is using excluding redundant terms. You might not be knowing what is redundant. That is reason. Just hold on. I will discuss this question after completion of KMAP. This is also very simple question. It is expected 1, 6, 8, 15. From F3 we are getting 115, and we are expecting here, what is it here? 6 and 8. What we have here in F1, 4, 5, 6, 7, 8. Go through your question papers, right? So F2, what should be F2 to get intersection is 6 and 8. Common should be 6 and 8. So from the options you can choose option is 6 and 8. Then intersection is 6 and 8. Then we are getting OR gate output is 1, 6, 8, 15. Why are you expecting 6 and 8? We are taking union of these. It must be resulting 1, 6, 8, 15. 115 we are getting from this. If you are getting 6 and 8 from this, it is sufficient. So for that, F2 should be option C, 6 and 8. Can result intersection common terms is 6 and 8. Then output of OR gate will be 1, 6, 8, 15. Simple question. It's already discussed the concepts. See, read the question from your materials provided or whatever you have. Here, it was not possible to display when you are adding image. It was not compressible. So let me read the question for you. Question number 5. Consider the following circuit composed at XOR gates and non-inverting buffers. The non-inverting buffers have delays delta 1 equals 2 nanoseconds, delta 2 equals to 4 nanoseconds as shown in the figure. Both XOR gates and all wires have zero delay. Assume that all gate inputs, outputs and wires are stable at logic level 0 at time t equals to 0. If the following waveform is applied at input A, how many transients at B during the interval from 0 to 10 nanoseconds? In this circuit, what is mentioned? There is a propagation delay. There is a propagation delay for buffers. Delta 1 equals 2 nanoseconds, delta 2 equals to 4 nanoseconds. And XOR gate delay is how much? 0. Y delay is 0. And A waveform is given. A is changing like this. Then how many changes are there in B? Transition means it may be from 0 to 1 or 1 to 0. How many changes are there in B in 10 nanoseconds? That is the question. Once again, in the given circuit, the delays are specified. What is that? Buffer delays delta 1 equals 2 nanoseconds, delta 2 equals to 4 nanoseconds, and XOR gate delay is 0. If A input is changing as specified, how many changes are occurring in B in 10 nanoseconds? For that, very simple. Let me do that. First, let me draw the circuit to understand correctly. According to the given, this is there. Here, if it is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Let me draw one by one waveforms of each and every logic gate. What is it here? Here, A is already given. I need to draw output of buffer, which is A star. Which is A star. Let me draw that A star. It is A itself. Buffer output is A itself, but the changes are delayed by 2 nanoseconds. A is 0. A star also 0. A is changing from 0 to 1. A star is changing from 0 to 1 after 2 nanoseconds. Anyone has any questions? What we have drawn here is buffer output I have drawn. Right. So it is A star. A and A star. Now let me draw that XOR gate output. Let me say it is a P. Let me draw that P output. What is it here? XOR gate. 0, 0, XOR gate output is 0. 1, 0, XOR gate output is 1. For 1, 1, XOR gate output is 0. Right? This is what? XOR gate output. That is P. Anyone has any doubt? Because XOR gate propagation delay is 0, it must be shifted by 0 time. It will be same. Functional waveform and actual waveform become same when propagation delay is 0. Functional waveform must be shifted by propagation delay time. As propagation delay of XOR gate is mentioned 0, it must be shifted by 0 time, means it will be same. Now, I would like to draw buffer output P star. What is here? P star. What is P star? delayed version of P by how much time? 4 nanoseconds. How much is that? 4 nanoseconds. Yes, sir. This P waveform must be shifted by 4 nanoseconds. Yes, it is 0. Here it is changing from 0 to 1, must be shifted by 4 nanoseconds. That means at 5 nanoseconds is and once again it is changing from 1 to 0 at 3 nanoseconds, must be shifted by 4, means it is at 7 nanoseconds. Just move this P by 4 nanoseconds. From here to here, 4 nanoseconds. From here to here, 4 nanoseconds. Just shifting P by 4 nanoseconds. Yes, these two are inputs of XOR gate. Second XOR gate inputs are what? P and P star. Now considering these two as inputs, let me draw that B 0 0 XOR gate output is 0, 1 0 XOR gate output is 1, 0 0 XOR gate output is 0, again 0 1 XOR gate output is 1, and 0 0 XOR gate output is. Is that clear? 0 0 XOR gate output is 0, 1 0 XOR gate output is 1, 0 0 XOR gate output is 0, 0 1 XOR gate output is 1, 0 0 XOR gate output is 0. Yes. In this B, how much time it must be shifted? 0 time, because XOR gate delay is 0 only. So how much time it must be shifted? 0 time. In this, how many transitions or how many changes are there? 1, 2, 3, 4. How many changes are there? 4 changes are there. 4 transitions are there. Simple thing. Whatever we have discussed yesterday about propagation delay effects, we have been. Yes, sir. P star is nothing but right. P star means a delayed version of P. Am I right? What is P star here? Buffer output. What is input of buffer? P. So without changing any functionality, the P must be delayed by how much time? 4 nanoseconds. Yes. Here it is P. So here 0 to 1 must be delayed by 4 nanoseconds. And here 1 to 0 must be delayed by 4 nanoseconds. Otherwise, just from here to here, if you are moving, everything is shifted. Just throw it, move it. P waveform must be shifted or moved by 4 nanoseconds. Once we are getting P and P star, we are applying XOR function. Read the question. Let x1 XOR x2 XOR x3 XOR x4 equals to 0, where x1, x2, x3, x4 are Boolean variables, and this symbol is XOR operator. Which one of the following must be true? If x1 XOR x2 XOR x3 XOR x4 equals to 0, for this, which of the following must be satisfied? So when x1 XOR x2 XOR x3 XOR x4 is 0 means x1 XOR x2 XOR x3 XOR x4 is equals to 0 is indicating what is here? x1, x2, x3, x4 are not having odd number of ones. That means x1, x2, x3, x4 are having even number of ones. Understand correctly? x1 XOR x2 XOR x3 XOR x4 equals to 0 means it is not 1 means it is not having odd number of ones. It is not having odd number of ones means it is having even number of ones. What is that combinations of x1, x2, x3, x4? 0, 0, 0, 0. 0 number of ones. Correct? Next. 1, 1, 1, 1. Correct? 4 ones means it is even number of ones. If even number of ones are there, output is 0. When odd number of ones are there, output is 1. Next, 0, 0, 1, 1. Now we have 2 ones. 1, 1, 0, 0. For this also, XOR function is 0. 0, 1, 0, 1. Also, function is 0. 1, 0, 1, 0. Again, function is 0. 0, 1, 1, 0. Function is 0. 1, 0, 0, 1. Function is 0. Check it. Here we have 0 number of ones, 4 ones, 2 ones, 2 ones, 2 ones, 2 ones. So everywhere we have odd number of ones. If odd number of, everywhere we have even number of ones. If even number of ones are there, output is 0. When odd number of ones are there, output will be 1, XOR function. So for all these 8 combinations, the function specified will be 0. For all these 8 combinations, whichever the equation is true, that is the correct answer. Verification. Whichever the option is true for all these 8 combinations, verify with some of the options or some of the combinations. It becomes very easy. Option A can be eliminated. Why? It must be satisfying for all ones also. Yes, it is not there. Option B is also wrong because when x2 is 1, there it is failing. Or when x1, x3 are 1, 1, it is failing. Or this combination itself we can substitute. And when you are observing option D, is also what is that? X1 plus x2 plus x3 plus x4 equals 0 means except this, everywhere it is failing. When A, B, D are wrong, C must be correct. Think logically. When A is wrong, B is wrong, D is wrong, C must be correct. Then how can we get this expression C also? I'll show you that. If you are understanding A, B, D are wrong, C must be correct, we can go with option C. That is one method of answering this question logically, right? So I'll show you that how to get Sudha. What happened? Here 1001. What I have written here is 1001. 0110 complement is 1001. Yes. Focus on this question first. Once again, try to focus on this. What is given here? X1 XOR X2 XOR X3 XOR X4 equal to 0. If it is 0, then which of the following is true? Right? So X1 XOR X2 XOR X3 XOR X4 equals to 0 is indicating it is having even number of ones, because when odd number of ones are there in x1, x2, x3, x4, it will be resulting 1 because XOR function. When odd number of ones are there, then output is 1. When even number of ones are there, output is 0. That is XOR function. So in x1, x2, x3, x4, which combinations we can have a even number of ones? I am listing here. What can be that? 0, 0, 0, 0. 0 number of ones. It is even number of ones. 1, 1, 1, 1. 4 ones. Even number of ones. 0, 0, 1, 1. 2 ones. Even number of ones. 1, 1, 0, 0. 2 ones. 0, 1, 0, 1. 2 ones. 1, 0, 1, 0. 2 ones. 0, 1, 1, 0. 2 ones. 1, 0, 0, 1. 2 ones. So 0 number of ones, 2 number of ones, and 4 number of ones, which are even number of ones. Why we are considering this combination? XOR function is 0 is mentioned. Which combinations are resulting? These are the 8 combinations. So if x1 XOR x2 XOR x3 XOR x4 equals 0, which of the following is true means for all these combinations, the equation given must be true. Then option A, I am eliminating with 1, 1, 1, 1 combination because it must be satisfying for all. So I am substituting 1, 1, 1, 1 in this. It is resulting 1, but it is given 0. So option A is wrong. So now option B, x1, x3 plus x2 equals to 0. Simple. This combination itself we can substitute to eliminate option B also. Because it must be satisfying for all. Easily we can eliminate by using some of these combinations. It is resulting false. Now option D, if you are observing x1 plus x2 plus x3 plus x4 equals to 0. Substitute this combination itself. One logical or one logical or one logical or one is one itself. We are getting, it is given 0. Again, it is wrong. So when A, B, D are wrong, C must be correct. Otherwise, question is wrong. Otherwise, question galat ho jayega. So option C is correct with elimination method. Now let us see how is it done. Simple thing. What is it here? X1 XOR X2 XOR X3 XOR X4 is equals to 0. Right? Now you can rewrite this, right? Instead of X1, X2, X3, X4 order, you can write any order, because where it is one, it is not asked. How many ones are there? Doesn't matter where it is. So X1 XOR X3 XOR X2 XOR X4 is equals to 0. X1 XOR X3 XOR X2 XOR X4 equals to 0. Correct? Now, what can I write? X1 XOR X3 XORing with X2 XOR X4. Already we know that XOR can be implemented. XOR followed by XOR is giving multi-input XOR. So with that property, I'm writing this. I'm splitting XOR of these two, XOR of these two, XOR of these again. So X1 XOR X3 XORing with X2 XOR X4 is equals to 0. So if I say it is A, it is B, A XOR B is 0. A XOR B is 0. When is it possible? When A equal to B. Anyone is having any doubt? When two inputs are equal, output is 0. When two inputs are unequal, output is 1. When A XOR B is 0, A equal to B. Any doubt in that? Two input XOR function. So A is what? X1 XOR X3 is equals to X2 XOR X4. Right? Because we have written this into two parts. Then what we have observed is A is B. If I consider A XOR B is 0, A XOR B is 0 is true when A is equals to B, A is equals to B. Right. One more property also we know. What is that here? XOR with two bubbled inputs is equals to again XOR only, right? Right? That's what I'm applying here. X1 bar XOR X3 bar is equals to X2 bar XOR X4 bar. I'm complementing both the inputs. Functionality will not be changing. I'm complementing both the inputs. Functionality will be same. Then that is what is given option ticket. Right. If you have any questions, please hold on. I will discuss at the end when we are closing the session. Right. Read the question, everyone. A three input majority gate is defined by the logic function m of a comma b comma c equals to ab plus bc plus ca. Which one of the following gates is represented by the function majority of m of a comma b comma c whole bar comma m of a comma b comma c bar comma c? Read the question correctly. What is m of a comma b comma c is mentioned? Majority gate. What is expression is given? AB plus BC plus AC. AB plus BC plus AC will be 1 when AB are 1 1 or BC are 1 1 or AC are 1 1. That means when two inputs are 1, then output is 1. When ABC are 1 1 1, output will be 1. It is already discussed with respect to a logic gate circuit using NAND gates. PQ plus QR plus PR. PQ plus QR plus PR will be 1 when 2 or more of the inputs of P comma Q comma R are 1. In place of PQR, variables are changed. AB plus BC plus AC, PQ plus QR plus PR. Both are same. That means when 2 ones are there or 3 ones are there, then output is 1. Am I right? The expression of majority gate is m of a comma b comma c equals to AB plus BC plus AC. That is 1 when any of the two inputs are ones, or when three inputs are ones, then output is 1. When two ones are there, how many zeros will be there? When two ones are there, how many zeros will be there? Only 1. Because out of three inputs ABC, when two ones are there, how many zeros will be there? 0. When three ones are there, 0 number of zeros, right? Out of three inputs, when two ones are there or three ones are there, then output is 1. Am I right? Anyone who is having any doubt? The expression AB plus BC plus AC is similar to PQ plus QR plus PR, which is already discussed in logic gates. There, 2 or more of the inputs of P comma Q comma R are 1, then output is 1. That means any of the two inputs are 1s or three inputs are 1s, then output is 1. Similarly, here also, in place of PQR, it is used ABC variables. AB plus BC plus AC is resulting 1. Any of the two inputs are 1s, then output is 1. Either AB or BC or AC. When three inputs are 1s, also output is 1. That means when two ones are there, number of zeros is 1. When two ones are there, number of zeros is 1. That means number of ones is more than number of zeros. When three ones are there, number of zeros is 0. 3 ones, 0 number of zeros. That means again number of ones is more than number of zeros. Finally, what is that here? Majority ones are there. What is majority ones? Number of ones is more than number of zeros. That's what I've been confirming. Sajjan Singh. What I'm confirming here? Majority ones is nothing but number of ones is more than number of zeros. Their output is 1. That is majority function. Understand correctly? Very good meaning is there in the question itself for each and every word. Just observe correctly to answer this question. So I have included some typical questions only in classroom practice questions. So there you need to spend time to understand a question correctly. So to understand question, you may find difficult. That is the reason I have included these questions in classroom practice questions. AB plus BC plus AC means AB plus BC plus AC will be 1 when two ones are there or three ones are there. When two ones are there or three ones are there, then output will be 1. When two ones are there, Shubham Kumar, from the expression, if you are observing, AB plus BC plus AC will be 1 when any of the two inputs are 1s, then output is 1. When three ones are there, output will be 1. The majority function expression is giving that. M of A comma B comma C equals to AB plus BC plus AC means this expression is resulting 1 when two ones are there or three ones are there in three inputs. When 2 ones are there, how many zeros will be there? Only 1 zero. When 3 ones are there, how many zeros are there? Zero number of zeros. Then finally, what is it here? When number of ones is more than number of zeros, there it is resulting output 1. Yes. Yes, Sahil Singh. Yes. Then just remember this, we need to evaluate this expression. Very simple. Looks like just we need to spend time in understanding the question. Remaining is very easy. Observe correctly. What is given here is m of a comma b comma c equals to ab plus bc plus ac. And what is required to find m of a comma b comma c whole bar comma m of a comma b comma c bar comma c. This is what we need to analyze. Right? Simple thing. A, B, C possible combinations. 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Right? 0, 0, 0 to 1, 1, 1. Right? All possibilities. Now, let me write one by one. M of A comma B comma C. First one, let me write. Next, M of A comma B comma C whole bar. Follow correctly. First, we write M of A comma B comma C. Next, let me write complement of that. Third one is M of A comma B comma C bar. What is it here? After complementing C, observing majority ones are there or not. This is the third one. Then third. Next is. Now, what is F? Function of these. What is it? Majority of these three. Correct? Check it correctly. What we need to find is F. F is nothing but a majority of these three. So first, let us write these columns for each and every combination of these three. Let us see majority is there or not. So with respect to given, I'm writing one by one. So 0, 0, 0. Majority function will be 0. 2 ones or 3 ones, then output is 1. Right? Majority ones are there, output is 1. For 0, 0, 0, majority ones are not satisfied. 0, 0, 1. Again it is 0. Right? So 0, 1, 0. Again it is 0. Why? We don't have 2 ones, we don't have 3 ones. 0, 1, 1. Yes, sir. Majority ones are there. 1, 0, 0. Majority ones are not there. 1, 0, 1. Majority ones are there. 1, 1, 0. Yes, majority ones are there. 1, 1, 1. Majority ones are there. See, in this 2 ones are there. In this 2 ones are there. In this 2 ones are there. In this 3 ones are there. Then, what is it here? Complement of this. Let me write. I hope everyone is following. 1, 1, 1, 0. Complement of this column. Next, 1, 0, 0, 0. Correct? Now, let me write this column. What is it here? M of A comma B comma C bar. That means for each and every C value after complementing observing majority ones. Check it correctly. What is it here? I need to write this column. 0, 0, 0. Here, 0 should be complemented, then observe number of ones. Then what is it here? 0, 0, 1. Majority ones are there? No. Then it is 0. Next, 0, 0, 1. 1 complement is 0. Now inputs is 0, 0, 0. Majority ones are not there. Then it is 0. Then again, what is it here? 0, 1, 0. That means 0 complement is what? 1. So if it is 1, 0, 1, 1. 0, 1, 1. Majority ones are there. Then it is 1. Any questions, sir? For this 0, 1, 0, after complementing this 0, it becomes a 0, 1, 1, 2 ones. Yes, sir. It is 1. Next, 0, 1, 1. 0, 1, 1. 1 complement is 0. Then 0, 1, 0. Majority ones are not there. Then function is next. 1 0 0. 1 0 0 means 0 complement is 1 because A B C bar. So after complementing C, it becomes 1. 1 0 1. Yes, majority ones are there. There it is 1. Then once again 1 0 1. 1 0 1 means 1 complement is 0. 1 0 0. 1 0 0 means majority function is 0. Am I right? Now 1 1 0. 0 complement is 1. So it becomes 1 1 1 inputs. Then majority ones are there. Function is 1. 1 1 1. 1 complement is 0. Then 1 1 0. Majority function is 1. Majority function is 1. Then C. What is C? 0 1. Directly copying from this column. C. 0 1. Next step. 0 1 0 1 0 1. Then what is it? F, majority of these three. Then apply majority for these three. I hope you are observing correctly. Follow correctly. I am applying majority for these. 1 0 0. Majority function is 0. 1 0 1. Majority function is 1 because two ones are there. 1 1 0. Majority function is there. So 1. So 0 0 1. Majority is not satisfied. 1 1 0. Majority is satisfied. 0 0 1. Majority is not satisfied. 0 1 0. Majority is not satisfied. 0 1 1. Majority is satisfied. I hope everyone is following without any doubts. Right. See, let me write expression for F. Here it is 1. Which combination of A, B, C? This one. What is that? 0, 0, 1. A bar, B bar, C. Here it is 1. Which combination of A, B, C? 0, 1, 0. That means A bar, B, C bar. Plus here it is 1. Which combination of A, B, C? 1, 0, 0. A, B bar, C bar. And here it is 1. Which combination of A, B, C? A, B, C, 1, 1, 1. Right? Once you are writing expression with respect to A, B, C for F, which we are calculating. Then in this, if you are observing, C is 1, B is 1, A is 1, and A, B, C are 1. One input is 1 or three inputs are 1. Right? C is 1, B is 1, or A is 1, A, B, C are 1, 1, 1. Then function is 1. Which function is that? Which function is that? One input is 1 or three inputs are 1, then output is 1, which is odd number of 1, then output is 1, which is XOR. XOR. Simple thing. Right, one by one. ABC combinations I have written. And first one is majority of ABC. If two ones are there, three ones are there in ABC, we are writing. And next column is what? Complement of this first column. Here, complement of this. Then what about this? For each and every ABC, after complementing C, observing number of ones. And after that, directly C is copied here. Why we are writing these? These three, we need to apply majority function. M of A comma B comma C whole bar, comma M of A comma B comma C bar. Here it is C. Right? Now C we have written there. And what about F? Majority of these three. So 1 0 0. Majority ones are not there. 1 0 1. Majority ones are there. 1 1 0. Majority ones are there. 0 0 1. Majority ones are not there. 1 1 0. Majority ones are there. 0 0 1. Majority ones are not there. 0 1 0. Majority ones are not there. 0 1 1. Majority ones are there. Now F we are writing with respect to ABC combinations. F is 1 for ABC 0 0 1. So A bar B bar C. F is 1 for ABC 0 0 1. A bar 0 1 0. A bar B C bar. F is 1 for ABC 1 0 0. A B bar C bar. F is 1 for ABC 1 1. It is ABC. Then after this, if you are observing, if C is 1, function is 1. B is 1, function is 1. A is 1, function is 1. ABC 1 1 1, function is 1. One input is 1 or three inputs are 1, then output is 1, which is a three input XOR. That is A XOR B XOR C. Right? It is, answer is what? Answer is what? From the given options. 3 input NAND, 3 input XOR, 3 input NOR, 3 input XNOR. Correct option is 3 input XOR. Manikanta, you might be there in the class, sir. Please check it. In this option, we have 3 input XNOR also. Yesterday we talked so much time about this. Manikanta, if you are there, please reply. According to you, again, both options are correct. Yes, Ashutosh, I'll help you. Wait. Right? What is to be proven, you need to say now. Right? Yesterday you were asking me to prove something, right? Because something was there in your mind, there's a problem. So shift delete that, you can understand concepts correctly. Otherwise, I cannot help you. Ashutosh, now you understood? Okay, very good. Here, with respect to your concepts, should I choose B or should I choose D? It becomes a right ambiguity. Right. Thank you. Okay. This is the way we are solving. Try this question number 8. All the logic gates shown in the figure have a propagation delay of 20 nanoseconds. Let A equals to C equal to 0 and B equals to 1 until time T equal to 0. At T equal to 0, all the inputs flip. Flip means A was 0 becomes 1, C was 0 becomes 1, B was 1 becomes 0 and remain in that state for T greater than 0. Output Z is 1 for a duration of dash. Understand given information, right? And we can solve easily a simple question. So what is given circuit is a right. According to the given, A is at 0, B is at 1, C is at 0. At T equal to 0, all the inputs are flipping. That means A is becoming 1, B is becoming 0, because all the inputs are flipping. Then C was 0 is becoming 1. Right? At T equal to 0, the flippings are happening. At T equal to 0, the flippings are happening. Right? Now let us write one by one output waveform. To answer this question, let us write one by one waveform. right? First, let me draw B bar. Here what we have? B bar. How much delay for each logic gate? 2 nanoseconds. Now, let me draw B bar. I hope you are following. Are you there? Any questions? Yeah, 20 nanoseconds. Sorry, 20 nanoseconds. Okay. 20 nanoseconds. Each and every logic gate delay is 20 nanoseconds. Okay. Yes. So let me draw that B bar. B variations are known. We need to draw that B bar. B is 1, B bar is 0. B changing from 1 to 0. B changing from 1 to 0. B bar is changing from 0 to 1 after 20 nanoseconds. This duration is how much? 20 nanoseconds. 20 nanoseconds. Now, what is the next thing we need to do? AND of A and B bar. Let me draw that A and B bar as inputs. Let me draw that AND gate output. Let me mention it as X. Let me draw that X. So 0, 0, AND gate output is 0. 1, 0, AND gate output is 0. Here, both the inputs are becoming 1, 1. So AND gate output becomes 1. That too after 20 nanoseconds delay. After 20 nanoseconds delay. How much is this? 20 nanoseconds. That is X. That is X. Now, what is the inputs of XOR gate? What is the inputs of XOR gate? Tell me. X and C, right? X and C. Let me draw the Z functionally first. Considering these two as inputs, let me draw the Z. 0, 0. XOR gate output is 0. Here at this point of time, 1, 0. XOR gate output is becoming 1. For 1, 1, XOR gate output is 0. What is this functional output waveform? Must be delayed by how much time? 20 nanoseconds. So actual Z will be shifted version of this. How much time it must be shifted? 20 nanoseconds, right? Shifting by 20 nanoseconds. Now, what is this duration? Same as this. How much is this? 40 nanoseconds. How much is this? 40 nanoseconds. Simple question. Drawing waveforms one by one. You can answer. Answer is 40 nanoseconds. Kumar, don't add the delays. It depends on functionality. Go with that. Don't add delays of each and every logic. 20, 20, 20, 60 nanoseconds. Don't try with that. Kumar. Yes, sir. I'll do. Srikanth, I'll do. Everything I'll do. Don't worry. Right? Let me do one by one. Everything once again. For some of your friends, I'm explaining once again. First, let me draw that B bar. Here B is there. Now let me draw B bar. B is 1. B bar is 0. Here B is changing from 1 to 0. B bar is changing from 0 to 1 after 20 nanoseconds. Understand correctly? This is 20 nanoseconds. What is the inputs of AND gate? A and B bar. Check it correctly. The inputs of a AND gate is A and B bar. Considering these two as inputs of AND gate, let me draw that AND gate output is X. Let me draw that X. For 0, 0, AND gate output is 0. For 1, 0 also AND gate output is 0. For 1, 1 AND gate output is 1. But you are expecting 1 here. No, after 20 nanoseconds delay, because AND gate delay is also 20 nanoseconds. Each and every logic gate delay is 20 nanoseconds. Now, what is the inputs of XOR gate? X and C. Yes, here we have inputs considering X and C as inputs. Let me draw that XOR gate function. So XOR gate output is Z. Let me draw functionally first. These two, observe these two. One is C, other one is X. So 0, 0, XOR gate output is 0. At this point of time, 1, 0, XOR gate output is 1. Till this, no changes in X and C. At this point of time, C already 1, X is becoming 1. For 1, 1, XOR gate output is 0. This is a functional output waveform of Z. It must be delayed by how much time? 20 nanoseconds. Yes, 0. It is 0 to 1 should be delayed by 20 nanoseconds. And again, it must be here to here 20 nanosecond, here to here 20 nanosecond. This is a 40 nanosecond duration means it will be 40 nanoseconds. Finally, output Z is 1 for 40 nanoseconds. Read question number 9 in your classroom practice questions. A universal logic gate can implement any Boolean function by connecting sufficient number of them appropriately. 3 gates are shown. Those 3 gates are, it is missing. One is OR gate is there. It is missing. OR gate is gate 1, AND gate is gate 2, and gate 3 is already visible here. Which one of the following statements is true? Gate 1 is universal, gate 2 is universal, gate 3 is universal. None of the gates shown is a universal gate. Yes. Very good, Anand, for remembering. Yes. Gate 3 is universal. Yes, gate 3. Right. So like that, we have some more questions, statement-wise questions for ESC students in classroom practice questions. Try. If you find any difficulty, let me know. I'm there to help you. Any questions in these? Whatever we have discussed in these, do you have any questions? Delay of Z means what? It will not be asked delay of Z. So the other way questions you will get Nagalingeshwar Rao. I'm going to talk about that, how much time it takes to stabilize the output, delay of output, what is the delay of circuit. Such questions I'm going to talk in combination circuits under that. Hold on. So when input variations are given, they won't ask that what is the delay of output. It is not like that. What is it here? How much time output is 1, how much time output is 0, how much time it takes to get output 1 from this t equal to 0. This type of questions you can expect. But what is the propagation of a logic circuit? What is the time required to stabilize the output and so on? And so all such questions we are going to see in combination circuit. Right? Please wait. Triveni, I will give you chance at the end. If you have any doubts, please type in the chat box. Right, with respect to the questions we have discussed. Yes, statement questions only for ESC. Seventh question. Why you won't take a I will show you that Shubham Kumar for your question. I will give you answer in combination. Good, until that, hold on. How to calculate propagation delay and all. Bhaskar, what is that you are saying? Just let me go to that seventh question. You are taking 111 or 1. Then what happens? Yugasri, the same question which we have discussed as ACE gate. P bar plus Q. Here variables are changing. What is the output we are getting? X bar plus Y. It's only difference. Variables are changing. Yugasri. Yes, Ashutosh. I'll discuss all those, sir. When I find time, please. Let me go with this, sir. Venkana, you don't need to worry about conventional now. First, focus on objective. I'm sure I'll help you in that conventional also. Question number 7. Let me go to question number 7. Many are talking about question number 7. Let us see what is that. What happened? AB plus BC plus AC is becoming 1. AB plus BC plus AC is becoming 1. What is it here? 1 1 or 1 1 or 1 1. So AB are 1 1 or BC are 1 1, AC are 1 1. Other one can be 0. Right? M is 1 majority. 1 majority. If it is A, for example, A bar B bar plus B bar C bar plus A bar C bar is there. This is now majority zeros. Check it correctly. When AB plus BC plus AC is there, majority ones. When A bar B bar plus B bar C bar plus A bar C bar is there, then majority zeros. Bhaskar and Prasad Pradhan, right? Right. Okay. With that, we have done with the Boolean algebra logic gates, right? Before getting into next topic, let us take a small break. We'll continue after the break. 15 minutes from now. We'll resume in 15 minutes and we'll continue. Right. Welcome back. I hope everything is clear with K-map we have discussed. Sorry, with logic gates we have discussed. Boolean algebra, logic gates, and also number systems. The next topic is K-map. K-map is a corner map. What for it is a minimization of Boolean expression. What is speciality of corner map? Arranging input combinations which are differing in only one bit side by adjacent. Arranging input combinations which are differing in only one bit side by. Once again, K-map is corner map is used for minimization. What is speciality of corner map to use for minimization? Arranging input combinations which are differing in only one bit side by adjacent. How it becomes easy if you are arranging such that we will understand soon. But what is the base for K-map? Is gray codes. The base for K-map is gray codes. Based on the gray codes, it is arranged combinations adjacent in K-map. Once again, based on gray codes, it is arranged all the combinations which are differing in only one bit side by adjacent. Which one is helping here? Gray code. What is gray code first of all? When I'm using n bit combinations, n means 2 power n input combinations. So n bit combinations are arranged such that successive representations are differing in only one bit and last and first also differing in only one bit. Point should be understood correctly. Successive representations are differing in only one bit, last and first also differing in only one bit. What do you mean by this? For example, if I consider 2-bit gray code, how gray codes are helpful we see later. First, let us introduce gray codes. I am introducing here gray codes. I am going to do that conversions later. So, if I say 2-bit gray codes, that means 2-bit combinations, right? One after the another, if you are arranging, successive representation must be differing in only one bit. Last and first also must be differing in only one bit. So, what is it here? 0, 0, 0, 1, next 1, 1, next 1, 0. Why you are using after 0, 1, 1, 1? So if I am using 0, 1, next 1, 0, if I use 1, 0 here, 2 bits will be changing. If I use 1, 0 here, 1 bit is here, 1 bit is here. 2 bits are changing. That is not acceptable. What is acceptable here? 1 bit difference is acceptable. So after 0, 0, 0, 1, next number is what? 1, 1, next 1, 0. So 1 bit difference, 1 bit difference, 1 bit difference, last and first also differing in only 1 bit. That is a property of gray codes. Successive representations are differing in only one bit. Last and first also differing in only one bit. That is a gray code property. If it is 3-bit gray codes, follow correctly. 0, 0, 0, next 0, 0, 1, next 0, 1, 1. 1 bit difference. Next 0, 1, 0, next 1, 1, 0, 1 bit difference. Next 1, 1, 1, next 1, 0, 1, next 1, 0, 0, 1, 0, 0. What is it here? 1 bit difference. Observe each and every representation with successive representation, only 1 bit difference. Last and first also differing in only 1 bit. Last and first also differing in only 1 bit. So successive representations are differing in only 1 bit and also last and first also differing in only 1 bit. Yes, that is 3-bit gray code. 4-bit, no need to remember. K-map will help us in writing gray codes also. K-map is arranged, or input combinations are arranged in K-map based on gray codes. Gray codes property, if you are observing, successive representations are differing in only 1 bit and last and first also differing in only 1. So how to write 4-bit and 5-bit we see later. Until that, hold on. Okay, understood. But what will be the use of this arrangement? Let us see how it is arranged, how these are helpful in minimization of Boolean expression. If I take a 2-variable K-map, for example, 2-variable K-map. Here, we need to understand one important word, which is nothing but adjacency. What is adjacency? In K-map, squares or cubes, if you say, you can say squares, you can say cubes. Why we say cubes, you can understand later. Until that, hold on. So at this moment, squares, successive squares, if they are sharing an edge, those are adjacent. Each and every combination is represented by a square. So whichever the squares are sharing an edge, those are adjacent. Those are adjacent. See here, 2-variable K-map, if you are observing, A, B, what we have here, 0, 1, 0, 1. If I write combination numbers, AB00 is 0, AB01 is 1, AB10 is 2, AB11 is 3. If you are observing 0 and 1 are adjacent, 1 and 3 are adjacent, 2 and 3 are adjacent, 2 and 0 also adjacent. 0, 0, 0, 1 adjacent, 1 bit difference. 0, 1, 1, 1 adjacent. How do you confirm adjacent? Because there is sharing of an edge. So this combination sharing an edge. These two are adjacent because sharing of edge. These two are adjacent because sharing of edge. These two are adjacent because sharing of edge. So 0, 0, 0, 1 adjacent, 1 bit difference. 0, 1, 1, 1 adjacent, 1 bit difference. 1, 1, 1, 0 adjacent, 1 bit difference. 1, 0, 0, 0 also 1 bit difference. Yes. So adjacent squares or adjacent combinations in K-map differing in only 1 bit. If there is sharing of edge, those are called adjacent. If they are adjacent, they will be differing in only 1 bit. Yes. What is the advantage of this? Let us see. If I consider 2-variable K-map, if a function is 1 for adjacent combinations, if a function is 1 for adjacent combinations, if function is 1 like this, what can we write resultant? A bar B bar first term plus A bar B, because these are min terms. I hope you are understanding. AB00 function is 1 A bar B bar, AB01 function is 1 A bar B. If I take A bar common, B bar plus B. B bar plus B is 1, resultant is what? A bar. That's what we have been doing the same with respect to K-map also. As function is 1 for these two, though as those two are adjacent, grouping. If you are grouping, in that there will be a variable which is changing from 0 to 1. Yes, 0 to 1 changing, eliminated. A equal to 0 is not changing. In this entire grouping, A equal to 0 is not changing. So resultant is A bar. Observe correctly. Basics I'm discussing. Some of you may be familiar with these basics. Please hold on. The advanced topics in K-map also waiting for you. Please wait if you have already known to these concepts. Some people may be lagging in these concepts also, or you might have said long back. That is the reason I've been explaining all these basic points also. Please bear with me. Yes, if function is 1 for these two adjacent combinations, in which B changing from 0 to 1 should be eliminated. A equal to 0 is not changing. So resultant we are writing A bar. Similarly, if function is 1 for these two combinations, yes, B changing from 0 to 1 should be eliminated. A equals to 1 is not changing. So resultant is A. Right. Similarly, if function is 1 for these two are also adjacent, right? Sharing and these two are adjacent. So in which A is changing from 0 to 1, B equal to 0 is not changing. So it is B bar. And similarly, if function is 1 for these two, B equals to 1 is not changing. A equal to 0 to 1 is changing. So it is a B. It is B. Correct. If a function is 1 for all 4 combinations, now we can group quad, in which A is changing, eliminating, B is changing, eliminating. When both are eliminated, resultant is what? 1. When function is existing for all combinations, if function is 1, what is the function? F equals to 1 only. Because A is changing, doesn't matter. B is changing, doesn't matter. If it is not depending on A and B, function is 1. Because for each and every combination, function is specified, output is 1. What is it here? For all the combination, function is 1 means we are grouping it as a quad in which A is changing from 0 to 1, eliminating. B is changing from 0 to 1, eliminating. So when both are eliminated, resultant becomes 1. So the first thing is arranging input combinations such that adjacent cubes or adjacent squares are differing in only one bit. For that we are using order. What is it here? 0, 1, 3, 2. Again back to 0. That is gray code order. 0, 1, 3, 2. Back to 0. That is a gray code property. Yes. Here, if I'm using gray codes to arrange the input combinations, in that successive combinations are differing in only one bit. If successive combination function is 1, in which there will be a variable which is changing, should be eliminated, then writing resultant. Yes, if I'm grouping like this, B is changing from 0 to 1, eliminating, A equal to 0 is not changing A bar. Similarly, in these two, B is changing, A equals to 1 is not changing, so it is A. If these two, if you are observing, A is changing, B equal to 0 is not changing. In these two, A is changing, B equals to 1 is not changing. Right? That is a two variable K. If function is 1 for all the 4 combinations, then A is eliminated, B is eliminated. When both are eliminated, F is becoming 1. So we don't need to all these also. When function is 1 for all the combinations, it is not depending on A, it is not depending on B. Then function is 1. It is not required to design any system here. For this function, if function is 1 for all the combinations, yes, F is 1. F is 1. Now, if I take a 3 variable K map, observe correctly. If I take a 3 variable K map, let us arrange input combinations such that adjacent are differing in only one. After 0, 1, next is a 1, 1. Next 1, 0. Next 0, 1. If I write input combination numbers, right? A, B, C order, A is MSB, C is LSB. 0, 0, 0, it is 0. 0, 0, 1 is 1. 0, 1, 1 is 3. 0, 1, 0 is 2. Next 1, 0, 0 is 4. 1, 0, 1 is 5. 1, 1, 1 is 7. 1, 1, 0 is 6. Correct. If it is required to write gray codes, no need to worry about that gray code order. Simply use a 3 variable K map. So this is the order. 0, 1, 3, 2, 6, 7, 5, 4, and last and first again 0, 0, 0, 1, 0, 0. Again 1 bit difference. So 0, 1, 3, 2, 6, 7, 5, 4 is the order of gray codes. Here also, what is it here? 0, 1, 3, 2, 6, 7, 5, 4. No need to remember gray codes also. Simply, if you are able to arrange in the K map, just complete a cycle without break, then it is covering the combinations in gray order. Gray order. Yes. After understanding this, let us see what can be the adjacencies. What else we need to understand in the K map. Right. So these two are adjacent, these two are adjacent, these two are adjacent, these two are adjacent, these two are, these two are. So wherever there is sharing of it, those are adjacent. So function is 1 for these two, in which one variable is changing C 0 to 1 should be eliminated. A equal to 0, B equal to 0, A bar, B bar. Similarly, if function is 1 for these two, in which A is changing from 0 to 1, B, C 0, 1 are not changing B bar, C, and so and so. So wherever there is sharing of it, those are adjacent. But one more important thing we need to observe is if function is 1 for these two, then what happens here? This is A bar, B bar, C bar. Plus this is what? A bar, B, C bar. If I take A bar, C bar common, B bar plus B, then what is the resultant? A bar, C. Then what can we write from this, sir? So we are grouping like this, right? Then we are grouping like this. Why those are grouped? Those two are also allowing us to minimizing, or those two are also adjacent. Why? Those two are also differing in only one bit. Check it correctly. So 0, 0, 0, 0, 1, 0. That means only one bit difference. Those should be arranged side by adjacent. But that is not possible in 2D diagrams. But what we need to imagine is fold the K-map. So fold these two ends. Then this edge will be coincident with this. K-map is not flattened. K-map is closed. When K-map is closed like this, then two opposite ends will be adjacent. Then this edge, entire edge will be coinciding with this. And again, these two look like adjacent because at that time there will be adjacency. There will be sharing of edge. So edges also adjacent. Simple statement about this is not only sharing of edge, whenever you are observing edges, edges also adjacent. These two are adjacent. These two are also adjacent. So if these two are adjacent, what is the resultant? A bar, C bar. Because in these two, B changing from 0 to 1 should be eliminated. A equal to 0, C equal to 0 is not changing, A bar, C bar. Similarly, if function is 1 for these two, then in these two again, B changing from 0 to 1 should be eliminated. A equals to 1, C equal to 0. What is that here? A, C bar. A, C bar. A, C bar. It is A, C bar. A equals to 1, C equal to 0. It is a C bar. Similarly, these two are adjacent, these two are adjacent, these two are adjacent, these two are adjacent, these two are adjacent. And wherever there is sharing of it, those are adjacent. No need to worry about it. Extra, what we are observing, edges are adjacent. What we are observing here, wherever there is sharing of edge between two squares, those are adjacent. Not only that, edges also adjacent. So for this, better to imagine it is a closed K-map. It is not flattened. It is closed. So you need to imagine it in 3D, then you can understand the two edges also adjacent. Similarly, there are other possibilities which we need to observe in 3-variable K-map. 3-variable. Then, if I write a 3-variable K-map, A, B, C, 0, 0, 0, 1, 1, 1, 1, 0, 0, 1. Yes, these two are adjacent. These two are also adjacent. These two are adjacent to these two, then we can group it as a quad. So what do you mean by this, sir? For these four, we can say these are adjacent. What do you mean by this? If you are observing clearly, in these, BC are existing in 0, 0, 0, 1, 1, 0, 1, 1. When you are observing 4 is adjacent, which 4 can be adjacent? For example, these two are there, these two are there. Can I group like this, these 4? No. If 4 is adjacent means there must be two variables which are existing in 2 power 2 combinations. Be clear about this, sir. So two variables are existing in 2 power 2 combinations. Those 4 can be adjacent. In these, if you are observing, BC are existing in 0, 0, 0, 1, 1, 0, 1, 1. Then resultant is what? A bar. Is A bar. A equal to 0 is not changing. BC are existing in all possibilities. B is changing, C is changing. Now similarly, this is also a quad in which BC are existing in all possibilities. Then resultant is what? A. Similarly, these 4 is also adjacent, in which A is changing, C is changing, B equal to 0 is not changing, so it is B bar. So if you are observing AC are existing in 0, 0, 0, 1, 1, 0, 1, 1, all possibilities. Now similarly, if you are observing this is a quad, then what does it get? In which A is changing, C is changing, resultant is B. Similarly, these 4 is a quad in which A is changing, B is changing, C equals to 1 is not changing. So it is C. And again, these two are adjacent with these two. These two are adjacent with these two. That means this 4 is a quad. Then A is changing, B is changing, C equal to 0 is not changing. C equal to 0 is not changing. That means C bar. If function is 1 for all 8, again F becomes 1. If function is 1 for all 8, then F becomes a 1. F becomes a 1. So you can group quad, which is 4 cube grouping, in which two variables are existing in 2 power 2 combinations. Two variables are existing in 2 power 2 combinations. Those two variables combined can be eliminated. Right? That is a 3 variable K map. Now, if I write a 4 variable K map. Prashant, Bhima Shankar, Baradola. Wait, what happened? 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. Zero 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 one 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 zero. Zero 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 one 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 1 0. Why we are using 0 0 0 1 1 1? To maintain the adjacency. If I use 1 0, here they are adjacent, they will be differing in 2 bit. No, not acceptable. Right? Now, the combination numbers, if I write 0, 1, 3, 2. Next, 4, 5, 7, 6. Next, 8, 9, 11, 10, 12, 13, 15, 14. Right? If I would like to write 4-bit gray codes, no need to worry, simple. This is the order. Zero, 1, 3, 2, 6, 7, 5, 4, 12, 13, 15, 14, 10, 11, 9, 8. 0, 1, 3, 2, 6, 7, 5, 4, 12, 13, 15, 14, 10, 11, 9, 8. Right? That is the gray code order. First one is what? 0, 0, 0, 0. Last one is what? 8, 1, 0, 0, 0. 0, 0, 0, 0, 1, 0, 0, 0. It means 1 bit difference. Last and first also differing in only 1 bit. Yes. Let us understand 4 variable minimization also. Nothing is there to copy. Just revision. A quick revision I am doing on key map 0 1 1 1 1 0 0 0 0 1 1 1 1 0. Right? Now, according to our discussions, wherever there is sharing of edge, those are adjacent. Correct? Wherever there is sharing of edge, those are adjacent. And also, edges are adjacent. Left to right edges are. And top to bottom edges also adjacent. These two are adjacent. These two are adjacent. These two are adjacent. These two are adjacent. Left to right edges are adjacent. Top to bottom edges also adjacent. Right. So once again, wherever there is sharing of it, those are adjacent, and extra what we need to understand is the edges are adjacent. Left to right edges are adjacent, top to bottom edges are adjacent. Now, you can understand two cube groupings easily. If function is one for these two, we can group variable is changing, should be eliminated, writing resultant using three variable, using two cube grouping. Not only this, so this is addition with this is addition with this is addition with this is addition with these. Similarly, top to bottom, these two are adjacent, these two are adjacent, these two are adjacent, these two are also adjacent. Similarly, what else we can say? Four cube grouping. These two are adjacent with these two. Correct? Then what is the resultant? In these four, A is 0, B is changing, C is changing, D equal to 0. Then what is it here? A bar, D bar. Anyone has any question? If function is one for these two and also these two, we can group it as a quad in which B is changing should be eliminated. A equal to 0 is not changing, A bar. C equal to 0 to 1 changing, D equal to 0 is not changing, A bar, D bar. Similarly, if function is one for these two with these two, then what we get here? B, D bar. Similarly, function is one for these two plus these two, then what we get here? A, D bar. Similarly, if function is observed these two and also these two, then what we get? B bar, C bar. Correct? Function is one for these two plus these two, then what we get? B bar, D. Similarly, you can complete all those. Here it will be B bar, C. And also this, you need to observe, what is it? Let us see. These two are adjacent, right? These two are also adjacent. These two are adjacent, these two are adjacent. These two are adjacent to these two. A corner grouping, which is special grouping, which is a quad. Corner grouping is a special grouping. Check it correctly. So the green one, if you are observing, these two are adjacent, these two are adjacent, these two are adjacent, these two. Then what we get here it is B bar, D bar. B bar, D bar. Right? Then similarly, what is it here? It is a quad, it is a quad, it is a quad. It is a quad, it is a quad, it is also a quad. I'm writing all the possible quads. Not only these, what else we have? Horizontally, it is a quad. Horizontally, it is a quad. It is a quad. It is also a quad. And vertically, this is a quad. All these are possible quads. All these are possible quad. In each quad, there will be two variables existing in 2 power 2 combinations. Those two variables combinedly can be eliminated. And similarly, next to possible grouping in a 4 variable K map is what is next possible? Octave. 8 adjacent cubes we are grouping. What we are doing? 8 adjacent cubes we are grouping. What is that? Let us see. It is a quad. It is also a quad. This 8 can be adjacent. It is a 8 cube grouping. In this 8 cube grouping, correctly, if you are observing, B, C, D are changing, which are existing in all possibilities. What is that? 0, 0, 0, 0, 0, 1, 2, 1, 1, 1. All possible combinations will be existing in this octave. Which are those in this B, C, D? So, 3 variables are existing in 2 power 3 combinations. Those 3 variables combinedly can be eliminated. Then resultant is what? Y equal to 0 is not changing. Similarly, it is an octave in which again BCD are existing in all possibilities. So BCD are eliminated. A equals to 1 is not changing, so it is A. Similarly, this is an octave in which what we have here, B equals to 1 is not changing, A, C, D are changing. And similarly, these 4 are adjacent with these 4. We are getting here B bar, B bar. And also, what else we have here? Vertically, it is an octave. Then what we get here? C bar. It is an octave. It is C. It is an octave, which is a D. And these 4 with these 4 is an octave. So it is D bar. If function is 1 for all 16, f becomes 1. If function is 1 for all 16, f becomes 1. So octave means we are grouping 8 adjacent cubes in which 3 variables are existing in 2 power 3 combinations. So 3 variables can be eliminated. Yeah, Shubham, it's a backward and a forward. Backward and forward. Right. So it is grouping 8 adjacent cubes, eliminating 3 variables. Yes, sir. It is eliminating 3 variables, writing resultant is of 1 variable. See, one important minimization principle we are going to address. Everyone should follow. I'm going to use this later also. Be clear about this statement I'm going to give you, and with observation, not giving statement only. See, in 4 variable K map, we are grouping 4 adjacent cubes is nothing but 2 power 2 adjacent cubes, eliminating how many variables, sir? 2 variables. Am I right? And what is the resultant term? 4 minus 2, it is 2 variables. Am I right? In 4 variable K map, grouping 2 power 2 adjacent. What is that? Quad is nothing but 4. 4 is 2 power 2. 2 power 2 adjacent cubes, eliminating 2 variables. Resultant term is of 4 minus 2, it is 2 variables. In the resultant term is also we have 2 variables. Similarly, in 4 variable K map, when I am grouping 8 adjacent, what is 8? 2 power 3 number of adjacent cubes, eliminating 3 variables. And the resultant is what? 4 minus 3, 1. 4 minus 3, 1 variable. Because in the resultant, how many variables we are observing? Only 1 variable. In 4 variable K map, grouping 2 power 2 number of adjacent cubes, eliminating 2 variables. Resultant is how many variables? 2 variables. In 4 variable K map, we are grouping 2 power 3 number of adjacent cubes. So there is 8. So 3 variables can be eliminated. Resultant term is of 4 minus 3, 1 variable. If I say m variable K map, grouping 2 power n number of adjacent cubes, eliminating n variables, resultant term is of m minus n variable. Observe it. In m variable K map, right, grouping 2 power n number of adjacent cubes eliminates n variable, because these n variables are existing in 2 power n input combinations. Then there is no dependency of n variables. So directly n variables can be eliminated because it is not dependent on n variable. Why? For each and every possibility of this n variable, function is 1. That means it is not at all depending on these n variables. That is the reason we are grouping 2 power n number of adjacent cubes as a group in which n variables are existing in 2 power n input combinations. So n variables combinedly can be eliminated. Resultant term is of m minus n. Yes, Sahil, I'm doing that only. Right? See what is happening here. In 4 variable K map, grouping 2 power 2 number of adjacent cubes, there is quad. How many variables are eliminated? 2 variables. If you are observing resultant, how many variables? 2 variables. There is 4 minus 2, 2 variables. In 4 variable K map itself, when I am grouping 8 octave, which is eliminating 3 variables, resultant term is of how many variables? Only 1 variable. That is 4 minus 3, 1 variable. Generalizing this, in m variable K map, grouping 2 power n number of adjacent cubes, eliminating n variables, resultant term is of m minus n variable. Right? Very good. Sahil Singh. Right. So important things we need to observe. What is that just grouping and writing? They are not concentrating on that. Simply elimination of variables, how many literals, these type of words they have been using in the question, theory questions. Don't take it easy. Every point I have been discussing is useful for competitive exams. Right? So, spending the valuable time to understand the concept in depth, not like simply grouping and getting expression. What is there in that? Even in graduation also we have done that. If you are not analyzing in depth, there's a possibility for getting confusions once again in the competitive exams, because from where they are framing questions, we don't know. Each and every point, each and every reason, you need to understand. Am I clear? Where is that arrow? I don't have any arrow. The four variable came up. Where is that arrow? Oh, this arrow, the order of the gray. So if you want to write 4-bit gray codes, 0, 0, 0, 0, 0, 1, 0, 1, 1, 0, 1, 0, next 0, 1, 1, 0. See here 0, 1, 3, 2, 6, 7, 5, 4, right? Then 12, 13, 15, 14, 10, 11, 9, 8. That's what we have used earlier also. In this also, if you're observing, see here it is 0, 1, 3, 2, 6, 7, 5, 4. Right? Top left. What is, okay. Yes. Understood, right? Yes. Ankur Kashyap. I'm going to do that only. If you are interested, I'm there to help you. Yes, sir. Okay. Okay. So that is about 3 variable, 4 variable. So finally, what we have observed is this is observation about minimization principle. What is it here? In m variable function, if n variables are existing in 2 power n combinations, those n variables combinedly can be eliminated. The point is a variable is existing in both 0 and 1 possibilities means the variable can be eliminated. When we are coming to 2 variables, 0, 0, 0, 1, 1, 0, 1, 1, all possibilities, 2 variables, 4 possibilities it is existing. If 3 variables, 2 power 3 possibilities it is existing. If n variables, 2 power n combinations, it is existing as function 1. Then those 2 power n variables, 2 power n combinations, we can eliminate, or n variables can be eliminated combinedly. Because n variables are existing in 2 power n input combinations means is these 2 power n combinations, if you are observing n variables existing in all possibilities, so it is not depending on n variables. It is not depending on n variables means eliminating n variables. That's it. Simple thing. With respect to K-map, what we say? Grouping 2 power n number of addition. When can we group? When they are adjacent. When they are adjacent, when they are existing in all possibilities. That's it. That's here. Generally, what we can say, if n variables are existing in 2 power n input combinations, that means irrespective of this n variables, functionality is something, right? So, with respect to this, what we can say, function is not depending on these n variables. These n variables can be eliminated because n variables are existing in 2 power n input combinations. So, it is independent of this n variable. That's what we can say. When we are grouping 2 power n input combinations also, that's what we are doing. N variables are existing in 2 power n input combinations. Because of that only they are becoming adjacent. Right? Adjacency is defined 2 squares sharing of edge. When we are coming to 4 squares, that means 2 variables are existing in 2 power 2 combinations. 8 squares, 3 variables are existing in 2 power 3 combinations. 2 power n squares, n variables are existing in 2 power n input combinations. Then n variables combined can be eliminated. Right? Right. If you are understanding this, next is Let me talk about the 5 variable K-map also. Little bit is required. When we are observing 5 variable K-map, what can we do? 2 4 variable K-maps we can do. What is it? Let us see. Two 4 variable K-maps. Then what we say? A equal to 0, A equals to 1. Next, B, C, D, E. 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. Again here, B, C, D, E. 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. Then minimizing in B, C, D, E, then what we take here? A bar and expression. In this K map, what is here? Minimizing in BCDE variables, we are getting an expression that we append with A bar. And here, A equals to 1, A, and minimal expression of this K map in BCDE. That is another expression. Then if function is 1 for, if you are using min terms, that is SOP, then we take R of this. Then what is it here? Further minimization is required. Further minimization is required. Correct? So A bar expression in BCD, A expression in BCD. Again, there may be possibility for further minimization. So again, we are using Boolean axiom. Now where we are observing K-map methods, right? So instead of this, we can use alternative method. Let us see what is that. See, in this what we are observing, one is for A equal to 0, one is for A equals to 1. And minimizing in BCDE variables appending A bar, this is one term. And second term is A equals to 1 K-map A, and again minimizing in BCDE. Right? Again, if there is any possibility for simplification, we are going to do that. But we have a disadvantage of this method. What is that? Let us understand. Here it is 1, here it is going to get. For example, with respect to this, you may be getting A bar, B bar, C bar, D bar, but here it is neglected. But in reality, these two are differing in only one bit. Am I right? These two are differing in only one bit. Am I right? Here it is A bar, B bar, C bar, D bar, E bar. Here it is A, B bar, C bar, D bar, E bar. That means A equal to 0, A equals to 1. Difference is only one bit for these two combinations. Those two are also adjacent. Right? But here it is not possible to analyze in that way. Because here you might have considered min term, but this don't care may be utilized in this K map, may be neglected. But in reality, there is a possibility for adjacency. There is an overlapping, then we can use that. Or we can use for minimization also. But if you are minimizing separately these two K maps, there may be possibility, there may be missing of this don't care effect. Try to understand this, sir? So that should not happen. As a reason, I use an alternative method for this 5 variable K map. Let us see how is it. I write a 4 variable K map. Right. This is for A equal to 0. This is for A equals to 1. and common is B, C, D, E variables. Common B, C, D, E variables. Then what we are observing? In this cube position, we have two cubes. Am I right? One from A equal to 0, one from A equals to 1. Observe correctly, understand correctly, which may help us in answering some of the questions based on 5 variable functions also. In this cube position, now we have two cubes, one from A equal to 0, one from A equals to 1. B, C, D, E common 0, 0, 0, 0. So these two combinations are differing in only one bit. These two combinations are differing in only one bit. Those two are adjacent. Every cube position, now we have two cubes. Those two cubes are also differing in only one bit. In every cube position, there are two cubes. Those two cubes are differing in only one bit. Those two cubes are differing in only one bit. Those two are also adjacent. Adjacent. See how we analyze. Whatever the adjacencies so far we have discussed, in 4 variable K map are applicable in respect to A equal to 0 and respect to A equals to 1 K map. Those are applicable. And extra, what we are observing, in every cube position, there are two cubes. Those two are also differing in only one bit. Those two are adjacent. Try to understand this once again. Clearly, I'm explaining. I'm using one upon another. One is for A equal to 0, another one is for A equals to 1. Those two are also adjacent. So in every cube position, we have two cubes, one from A equal to 0, one from A equals to 1. Remaining variables are common, that is adjacent. Whatever the adjacencies so far we have discussed on 4 variable K map are applicable here. And extra, every cube position we have two cubes. Those two are also differing in only one bit. Those two are also adjacent. Right. Now, for example, if a function is 1 for these two combinations, then what will be the resultant? Function is 1 for these two combinations. Where are two combinations? One from A equals to 0, one from A equals to 1. That means A is changing. B, C, D, E are not changing. Then B bar, C bar, D bar, E bar. If function is 1 for these four combinations, where are 4? 2 from A equal to 0, 2 from A equals to 1. Then B bar, C. Why? B, C, 0, 1. And E is changing. D equal to 0. It is D bar. If function is 1 for these 8 combinations, 4 from A equal to 0, 4 from A equals to 1, then what is the resultant? BC. Correct. So if function is 1 for the 16 combinations, what is that? 8 from A equal to 0, 8 from A equals to 1. Resultant is what? D, because 4 variables can be eliminated. Now, other possibilities. If function is 1 for these two combinations, only from A equal to 0. Point should be understood correctly, my words correctly. So if function is 1 for these two combinations only from A equal to 0, then A bar, next B, C bar, next D bar. Why am I writing A bar? Because these are from only A equal to 0. If they are from both A equal to 0 and A equals to 1 would have been quad, would have been eliminated A also. Observe correctly. These two are from A equal to 0 only. So A bar, B, C bar, D bar. Similarly, if a function is 1 for these four combinations are only from A equals to 1, then A in which B is not changing and D is not changing. It will be ABD. It will be ABD. Check it correctly. You can analyze the two 4-variable K-map separately and again appending the expressions of minimizing and simplifying. Or if you are able to understand one upon another, we can arrange and we can specify the min terms and max terms, and also you can minimize. Right? That is just introduction about K-map. Introduction about K-map. Now let us see K-map minimization. K-map minimization. Anyone has any questions? You can type in your chat box. If anything is not clear, let me know. I'll help you. Wait, Bhaskar, you will understand about don't care, sir. If you are expecting everything should be explained, it takes again 1 more hour. Please be specific about your question. I will explain. Gray codes is nothing but 1 bit difference, right? 1 bit difference. How the A complements comes here in this, if you are observing, this is what I'm saying that these two are ones, two only. 2 from A equal to 0. 2 from A equal to 0. I'm not saying that here we have 4, but I'm writing only black. Reason is those are from A equal to 0 only. That is reason A bar. A is not changing because these two are from A equal to 0 only. So it is A bar. Next BC bar because BC 1 0 and D equal to 0, it is D bar. Here it is 4 from A equals to 1 only. I'm using red one. The red one is what? It is only from A equals to 1. So it is A. And here B equals to 1 is not changing. B. D equals to 1 is not changing. C. D. So here C is changing. E is changing. In these 4, if you are observing, A is not changing because you are saying that from A equals to 1 only. So A, B, D. If it is from both, first A will be eliminated. If you are grouping combinations from A equal to 0 and A equals to 1 K-map, so first A will be eliminated, then you can think of other variables. If only A equal to 0, we have two combination function is 1, which are adjacent. How can you get 4 there, Bhaskar? I will take, hold on, I'll take. Gray codes order. You don't need to remember the K-map. You want to write gray codes of this 5 or what? We are going to see how to convert from binary to gray also. Binary sequence you can write and gray sequence we can write. Simple thing, a simple concept. I'm going to discuss in combination circuit. Just understand the properties of gray codes. Sajjan Singh. So Manisha, whatever we are writing is observing the variables which are not changing. We are writing resultant, right? Five variable K-map when A equal to 0 and A equals to 1 separately. See, that's what I explained, Venkana. See, in this, you are saying that two combinations function is 1. Those two are also from A equal to 0. As A equal to 0, A bar is appended first because A is not changing because this is a grouping. Then what happens here? BC 1 0, BC bar and D equal to 0 is not changing. D bar, E is changing, should be eliminated. And similarly, if you come to this A equals to 1, here we are saying 4 in A equals to 1 K map. 4 in A equals to 1 K map, okay. So A is not changing, and in this B equals to 1 is not changing, and D equals to 1 is not changing. C changing, E changing in this 8. Check it correctly. In this quad, which is used red, which is only from A equals to 1, so A is appended first. B is not changing, B equals to 1. D is not changing, D equals to 1. Venkana. Yes. Our interest is instead of searching terms, we are arranging the terms which are differing in only one bit. If an expression is given, there you need to search for the terms which are differing in one variable. Raja, Raja the Raja, right? See, for example, it is given like this. Expression is given like this: A bar, B bar, C, A bar, B bar, C bar, A, B, C plus A, B bar, C. Then what do we do? We need to search for the terms which are differing in one variable. Instead of searching, if they are already arranged side by, Raja, if they are already arranged side by, how is it possible? By using gray codes. Why we are using gray codes? In gray codes only we are using one bit difference. If you are understanding concept in depth, you will enjoy the subject. There won't be any limits for digital subject for your information. I can make it easy without discussing anything. I can make it complex if I get into in depth. But some other subjects will be there. There are some methods. That is a concept. And beyond that, nothing will be there. But here, it is not like that. I can show you it is very simple by taking examples. What is there in that simple, right? That is the reason digital can be taught by anyone, and you also. It's very easy subject. You also can teach, but what level we can teach, that is depending on what level we are analyzing subject. Subject is very easy, but when we are getting into depth, there we can find difficulty of the subject because endless subject. So there is no limitation for that how much we are learning in this. Right. Right. If you are understanding this, we need to understand some terminology of minimization. Get relaxed for 2 minutes. Important thing, compulsory question from K-map based on this concept. We need to focus on that. Please get relaxed for 2 minutes. I will start the concept on K-map. We need to learn terminology of K-map minimization. I'm mentioning once again, in 2 minutes, I'm going to start. Rohit Rajendra Kulkarni, what you are asking, can 5 variable K-map represented by column 8? Yes, sir. But again, you need to understand it is fold. Again, you need to understand fold by using 3-bit gray codes. You can use. Yes, that you can do. Then again, you need to understand that the entire folding. If you can utilize that. Rohit Rajendra Kumar. Right. Let us understand the terminology of minimization. You are very busy in chat box. Right? Now let us understand the terminology of minimization. Please focus on this, understand correctly. Important thing, there may be confusions till now on this topic because every competitive exam we have been getting questions on this. Let me say what is that? F of a comma b comma c. If I consider a function like this, a bar b bar c plus a bar b c plus a b c plus a b c bar. A bar b bar c plus a bar b c plus a b c plus a b c bar. Now, just listen carefully. No need to write. Nothing is there to write. In these two, if I take common, what is that? A bar c. Then what happens here? B bar plus b can be eliminated. So in these two, if I take a bar c common, b bar plus b can be eliminated. If I take common in these two, what I can take common? bc. So a bar plus a again eliminated. If I take ab common in this, what is it? C plus c bar, c can be eliminated. Understand correctly? When I'm combining these two, I'm getting a bar c. When I'm combining these two, I'm getting bc. When I'm combining these two, I'm getting ab. Right. After this level, if I combine these two, is there any possibility for eliminating any of the variables? A bar c, b c, if I combine these, if I take c common, a bar plus b, is there any possibility for elimination? No. Then again, if I combine these two, is there any possibility for elimination of variable? No. If I combine these two also, there is no possibility for elimination of variables. So, from these terms, further elimination of variables is not possible without changing functionality. If I want to eliminate a bar, functionality is changing. Functionality changing. Without changing functionality, elimination of variables from these terms is not possible. Understanding? So, after this level, we are getting terms a bar c, b c, a b. From these, it is not possible to eliminate any of the variables further. Then these terms are called prime implicants. Prime implicants. I'm going to define clearly. Just hold on. prime implicants. A bar, B bar, C is not a prime implicant. Why? B bar can be eliminated. B bar can be eliminated. So A bar C is prime implicant. Why? Further reduction of this term is not possible. Elimination of variables is not possible. BC is prime implicant, cannot be eliminated variables. AB is a prime implicant, cannot be eliminated variables. Now A bar, B bar, C, A bar, B, C, A, B, C, A, B, C bar. These are not prime implicants. These are implicants. These are implicants. So these are prime implicant because further elimination of variables is not possible. Further reduction of term is not possible. So it is named as a prime implicant. Then how can I define prime implicant? The smallest possible term of a function from which there is no possibility for elimination of variables. The smallest possible term of a function from which there is no possibility for elimination of variables. A bar, B bar, C is not a prime implicant. Reason? Elimination of variables is possible. A bar C is prime implicant because elimination of variables is not possible, and so and so. So how can I define prime implicant? Is the smallest possible term from which there is no possibility for elimination of variables. Then it is called prime implicant. Now, these terms are called implicants. These terms are called prime implicants. Now, after this, let me write coverage of minterms by each and every prime. So 0, 0, 1, it is 1. 0, 1, 1, it is 3. 1, 1, 1, it is 7. 1, 1, 0, it is 6. Check it correctly. I'm writing minterm numbers. Now, A bar C is covering minterms 1 and 3. BC is covering minterms 3 and 7. AB is covering minterms 6 and 7. Right? Each and every prime implicant coverage we are mentioning. A bar C prime implicant is covering minterms 1 and 3. BC prime implicant is covering minterms 3 and 7. AB prime implicant is covering minterms 6 and 7. Right? Now, at this stage, you need to understand one more terminology, one more term. Let us see what is that. So, at this stage, my aim is to write a complete expression using prime implicant. Whether it is minimal or not, we discuss later. But our aim is to write complete expression using prime implicant. What do you mean by complete? Covering all the minterms. Covering all the minterms. Try to understand correctly. My aim is to cover all the minterms. My aim is to cover all the minterms using prime implicants. Using prime implicant, correct? Now, for that, let us see what is the possibility. Focus on this. I'm going to address one more important term, right? So, first thing, my aim is to cover all the minterms using prime implicants, which may not be minimal. I'm not worrying about minimal now, right? Now, A bar C is covering 1 and 3. BC is covering 3 and 7. AB is covering 6 and 7. So it has to cover all the minterms. We are looking for complete expression. Complete using prime implicants. Now A bar C is covering 1 and 3. To cover minterm 3, alternative prime implicant is there. To cover minterm 3, we have alternative prime implicant. To cover minterm 1, no alternative prime implicants. Once again, aim is to write a complete expression. Aim is to write complete expression which is covering all the minterms. For that, we are choosing prime implicants. While choosing prime implicants, we are going to observe one more important thing. With that only, we are going to define second term. What is it here? A bar C is covering 1 and 3. For covering 3, we have another prime implicant. For covering 1, for covering minterm 1, no alternative prime implicant. For covering minterm 1, no alternative prime implicant. Then, without using this A bar C prime implicant, completeness is not possible. Without considering A bar C prime implicant, completeness is not possible. Then A bar C is called compulsory in the expression. essential in the expression, which is called a essential prime implicant. What is it here? Essential prime implicant. Why this A bar C is becoming essential? To complete the functionality, A bar C is compulsory, must, which is named as a essential. Why A bar C is becoming essential? It is having a specialty compared to all. What is a specialty? So this is min term cover. This is a prime implicant covering min term 1, which is not covered by any other prime implicants. So it is becoming essential. Coming to BC. BC is covering 3 and 7. To cover 3, alternative is there. To cover 7, alternative is there. Then BC is not a compulsory, which is non-essential prime implicant. So BC is a prime implicant, but it is non-essential prime implicant. Why? Each and every min term covered by this prime implicant, we have alternative prime implicants. After finding all prime implicants, going through each and every prime implicant, we are observing whether it is compulsory or not, whether it is essential or not. When can we say it is essential? If it is having a specialty compared to all. What is specialty? It must be covering at least one min term which is not covered by any other prime implicant. Then we can say it is a essential. Coming to AB, it is covering 6 and 7. 7 is having alternative, but 6 no alternative. So because of 6 min term covered by this prime implicant is becoming again essential, compulsory. So A bar C is covering a special min term 1, which is not covered by anyone. So because of that, it is essential. BC is covering 3 and 7, but 3 alternative there, 7 alternative there. For each and every min term covered by this prime implicant, alternative prime implicants are there. So it is non-essential. AB is covering 6 and 7. 7 alternative there, but 6 no alternative. So because of 6 min term covered by this prime implicant, which is not covered by any other, so AB is becoming essential. Right? Two terms we have discussed. What is it here? Prime implicant, essential prime implicant. What is prime implicant? Smallest possible term of a function from which elimination of variables is not possible or further reduction is not possible without changing functionality. Then it is called prime implicant. When can we say it is essential? If it is having a specialty. What is specialty? If it is covering at least one min term. If it is covering at least one min term, which is not covered by any other prime implicants. It is not covered by any other prime implicant. Then it is called essential. Once again, if a prime implicant is covering at least one min term, which is not covered by any other prime implicants, then it is becoming essential. Such that what we have seen, A bar C is covering min term 1. It is not covered by any other prime implicant. AB is covering 6, so it is essential. BC is not having such special min terms, so BC is becoming non-essential. BC is becoming non-essential. Right? So, how do we define prime implicants, essential prime implicants? Let me explain. Prime implicant, further reduction of the term is not possible or further elimination of variables is not possible. Then it is called prime implicant. When can we say it is essential? If a prime implicant is covering at least one min term, which is not covered by any other prime implicants. If a prime implicant is covering at least one min term, which is not covered by any other prime implicants, that is called essential prime implicant. That is called essential prime implicant. Correct? So A bar C is covering 1 and 3. Specialty 1. AB is covering 6 and 7. Specialty is 6 because 6 is covered by this only. So it is essential. BC covering 3 already covered, 7 already covered. So it is not covering any special min term. So it is non-essential. And let us write a minimal expression. Let us write minimal expression. So f of a comma b comma c, let us write minimal expression. In the minimal expression, first is what? Essentials. Because without that, completeness is not possible. It may be minimal, whatever it be. You need to write first complete expression. To complete expression, the essentials are must A bar C. And also because these two are essential. What about BC? Is not required. Why? A bar C is covering 1 and 3, AB is covering 6 and 7, function is 1367. 1367 already covered. So if I include BC, unnecessarily complexity is increasing. Am I right? If I include BC, excluding BC, functionality is same. What is functionality? 1367 min terms. Yes, sir. A bar C is covering 1 and 3, AB is covering 6 and 7. So including BC, excluding BC, functionality will not be changing. Then it is called redundant, extra, unnecessary term. What is it here? BC is becoming extra, unnecessary. It is also called redundant term. BC is a redundant. Why? Including BC, excluding BC, functionality is not changing. There is no effect of BC, including and excluding. So such terms are called extra terms. Unnecessary terms should be eliminated, which are redundant. That here, redundant. Inclusion of a term or exclusion of the same term is not changing the functionality. Then the term is called redundant. One by one, prime implicant, essential prime implicant, and redundant term. Redundant term. Right? So it is redundant. So indirectly you can apply consensus law also. Right? A bar, B, C. B and C is extra term. So whatever we have understood with respect to Boolean algebra, Boolean basics, we need to understand with respect to K-map also. Because always we are interested to use K-map. We are interested to use K-map. So let us understand same terminology with respect to K-map. Because all these are useless for us, for our competitive exams. Which are useful? K-map. So let us see. Right. Surya Teja, including and excluding the term functionality is not changing. That is called redundant. Non-redundant, non-essential prime implicant. Right, redundant can be non-essential prime implicant. Remember these words. People may be having such doubts. I will clear all those doubts. All the redundants are non-essential, but every non-essential may not be redundant. How we understand that? What is here? Every non-essential may not be redundant, but every redundant is non-essential. What do you mean by this? Do we get non-essentials also in the minimal expression? Yes, we get. All those we discussed. Just hold on. So at this moment, what we can say, Pranita, that's what I've been saying, right? I will discuss clearly. I will give you clarity. All the confusions will be cleared. No need to worry at this moment. So in this minimal expression, we are getting non-essentials only. Reason is non-essentials are covering all the midterms. So every time minimal expression is not only essential prime implicants. There may be possibility for getting non-essentials also when all that will be cleared until that hold on. In this case, as essentials are covering all the midterms, minimal expression is only essential prime. Right? Are you understanding? So in this case, essential prime implicants are covering all the midterms. That is the reason in the minimal expression we are getting only essential, but every time it is not only essential. There is a possibility for getting non-essentials also in minimal expression. When? Hold on. At this moment, just understand there is a possibility for getting non-essentials also in minimal expression. Right? Right? We can define redundant in another way. Also, hold on. Clearly, we understand, right? So, what we understood here, prime implicant, smallest term. Essential prime implicant, speciality must be there. What is it? It must be covering at least one min term, which is not covered by any other prime implicant. And after that, what we are writing? Minimal expression. What we are writing in this? First, essentials. As essentials are covered, this is becoming redundant. This is becoming redundant. How can you confirm it is redundant? Including this term, excluding the term is not changing the functionality. So it is named as a redundant. Wait, Yogesh Kumar, I will give you all that. I don't give you any confusion, sir. After my discussion, you will get the clarity. I won't be in hurry to complete the syllabus, sir. That's what my main rules, sir. Right? I'm covering means you must be in a position to understand everything. That's what my aim. Right? Wait. I will give you the clarity which you are expecting. All the statements will be given. All the statements will be given. Right? Once again, right? So these are prime implicant. These two are essential, and essentials are covering all the min terms. So this non-essential is becoming redundant. Fine. Let us write K-map for the same. Understand correctly. I'm going to use K-map. We need to understand with respect to K-map clearly, because in the exam, K-map only will help us in finding prime implicants, essential prime implicants, redundant, minimal expression also. So I'm writing K-map. What is function sigma m of 1, 3, 6, 7? Any questions? Sigma m of 1, 3, 6, 7. Right. Okay. Now, if I group like this, is it wrong? Can't I group one cube? Yes, we can group. Whenever it is possible, one cube is also grouping. But in this, if I group like this, what is happening? Resultant is what? A bar, B bar, C. Correct? I am grouping to power n number of adjacent cubes. N is indicating number of variables can be eliminated. I can group to power 0 number of adjacent cubes also. To power 0 means only one cube we are grouping. Yes, it is possible to group to power 0. Example, if I say, some of you may be knowing already, for them, let me give you clarity. For example, it is like this. Then you are grouping like this, you are grouping this only one. One cube is possible. Whether here it is correct or not, we decide later. But one cube grouping is possible or not? Yes, it is possible. So when we are grouping to power n number of adjacent cubes, it can be 0 to m. What is m? Number of variable K map. To power 0 to power m groupings are possible. Right? This n is varying from 0 to m. I hope you are understanding. N is varying from 0 to m. You can group only to power 0 number of adjacent cubes. There is only one cube can be grouped. So if I'm grouping like this, resultant is what? A bar, B bar, C. According to our earlier discussion, it is not a prime implicant. Right? How many cubes we have grouped? To power 0 number of adjacent cubes we have grouped. What is this? 0 is indicating n value. What is n is indicating? Number of variables can be eliminated. Right? I am grouping to power n number of adjacent cubes. The n is indicating number of variables can be eliminated. I am grouping only one cube means to power 0 number of cubes. 0 is indicating number of variables can be eliminated from this. But in reality, what we are observing, there is a possibility for expansion of grouping. Including this one, there is a possibility for expansion of grouping. Correct? It is possible to expand the grouping. That means it is possible to increase n value. It is possible to increase n value. That means there is a possibility for elimination of variables. Then it is not a prime implicant. Right? Expansion of grouping is possible. Increasing n value is possible. Why? to power n. N can be increased 0, 1, 2, 3. That means 1 cube, 2 cube, 4 cube, and 8 cube, and so and so. That means n is increasing, expansion is possible. N increasing is not possible, expansion is not possible. After this 2, is there any possibility for 4? No. So, including these 2, it is not possible for 4 without changing functionality. That means using only min terms in this. If you are trying to expand, yes, it is covering max terms. If you are expanding like this, it is covering max terms. Yes. So, expansion of grouping is not possible. Expansion of grouping is not possible. That means increasing n value is not possible. Expansion of grouping is not possible. Increasing n value is not possible. Increasing n value is not possible. Elimination of variables is not possible. Elimination of variables is not possible. Is a prime implicant. Smallest possible term from which elimination of variables is not possible is a prime implicant. The same concept I am applying here. So, expansion of grouping is not possible. That means increasing n value is not possible. Increasing n value is not possible. Elimination of variables is not possible. Elimination of variables is not possible is a prime implicant. Simple definition for prime implicant. What is it? In K-map grouping, if grouping cannot be expandable, it is a prime implicant grouping. Simple thing. A grouping which cannot be expandable is a prime implicant grouping. Whatever we have discussed here, I'm applying here. Simple definition with K-map. What is it here? If K-map grouping which cannot be expandable can be called a prime implicant grouping, such that how many groupings are possible, we need to find. Understand correctly? So, what we have understood, finally, prime implicant is very simple, which is nothing but a grouping which cannot be expandable. समझ में आ रहा है? Right? Are you understanding? A simple thing is a prime implicant, a grouping which cannot be expandable. A grouping which cannot be expandable. Simple thing. Then, how many groupings are there such that which cannot be expandable in this? Yes, this is one more grouping which cannot be expandable. Am I right? This is another grouping which cannot be expandable. Can I expand this? No. Yes, this grouping, prime implicant. This grouping, prime implicant. This grouping is also prime implicant. Should not think of whether it is required or not while analyzing for prime implicant. Clearly mentioning that while analyzing for prime implicant, don't think of whether it is required or not required in the expression. Grouping which cannot be expandable is prime implicant. How many prime implicants are there in the function? When such questions are asked, you need to find all possible groupings which cannot be expandable, irrespective of whether it is required or not required in the final expression. Point should be understood correctly. Don't get deviated from my words. So now, what is prime implicant? Grouping which cannot be expandable is prime implicant. So how to find number of prime implicants? Number of possible groupings which cannot be expandable, irrespective of whether it is required or not required in the final expression. Now, how many prime implicants possible? 3 prime implicants possible. In this function, 3 prime implicants. 1, 2, 3. While concentrating on prime implicants, please don't think of whether it is required or not required in the final expression. Please make a note about this as a caution. Please follow this correctly. When number of prime implicants is asked, you should not think of final expression. What should I do? I need to find all possible groupings which cannot be expandable. Required or not required, we decide later. But first thing is what? How many possible groupings are there which cannot be expandable? That is number of prime implicants. Here, how many groupings are possible? How many groupings are possible? 3 groupings are possible. So, number of prime implicants is 3. Number of prime implicants is 3. Number of prime implicants is equals to number of possible groupings which cannot be expandable. So, number of prime implicants of this function is 3. Now, second thing is what? Deciding essentiality. Deciding essentiality. What is the essential? Let us see. What we discussed about essential prime implicant, if a prime implicant is having a specialty, what is specialty? It is covering at least one minterm which is not covered by any other prime implicants. If a prime implicant is covering at least one minterm which is not covered by any other prime implicants, then it is called essential. Here, very simple. Coming to K-map, very simple. What is it here? In this grouping, special cube is there, essential. In this grouping, special cube is there, essential. In this grouping, special cube is not there, non-essential. The groupings which are covering at least one cube, which is not covered by any other groupings, is called essential prime implicant grouping. Once again, what is it here? Essential prime implicant is nothing but a prime implicant grouping which is covering at least one cube or one square, which is not covered by any other prime implicant groupings. Then it is called a essential prime implicant. In this, if you are observing, it is having a special cube. This cube is covered by this grouping only. This grouping is becoming essential grouping. Am I right? In this grouping, it is having a special cube. In this grouping, it is having a special cube. In this grouping, no special cube because it is covered by this grouping. It is covered by this grouping. This grouping is not having any special cube. So it is non-essential prime implicant grouping. Right. Two things once again with respect to K-map. Simple way we can understand. What is prime implicant grouping? A grouping which cannot be expandable. A grouping which cannot be expandable is prime implicant. Right? What is essential prime implicant? A prime implicant grouping which is covering at least one cube which is not covered by any other prime implicant group. Then it is called essential. After finding all prime implicant groupings, going through each and every grouping, if that grouping is having at least one special cube, it can be more than one cube also, not a problem. But at least one cube is there which is not covered by any other prime implicant groupings. That is called essential prime implicant grouping. Right. Essential prime implicant grouping. When is it? If it is having a specialty. What is that here? It is covering at least one special cube which is not covered by any other prime implicant groupings. Then it is called essential prime implicant grouping. Now, after this, if you are observing coverage of minterms by essentials, yes, sir. These two essentials are covering all the minterms. Am I right? These two. This grouping is covering two minterms. This grouping is covering two minterms. So these essential groupings are covering all the minterms. So minimal expression is what? This grouping is a bar C. This grouping is A B. A B. A bar C. A B. Any questions? This grouping is A bar C. This grouping is A B. What about this? Not required because already all the minterms are covered. Right? So this is redundant. Now you need to understand redundant correctly. What is it here? A non-essential prime implicant. It is covering minterms which are covered by essential only. Then it becomes redundant. Be clear about this. A non-essential prime implicant. It is covering minterms which are covered by essential prime implicants only. Then it becomes redundant. Clearly, you need to understand. Every non-essential is not redundant. Which one is redundant? If non-essential is covering minterm which are covered by essentials only, then it becomes redundant. What is redundant? Extra term. What is extra? We don't need to consider. When is that? When essentials are covering all the minterms. Right? If you are observing, non-essential is covering minterms which are covered by essential only. So one is covered by other essential, one more is covered by one more essential. Then finally, the minterms which are covered by this non-essential, already covered by essentials. Everything is covered by essentials. Right? This non-essential is one by one. Let us understand clearly. Please focus on this. I'm spending effective time. Right? Right. What is prime implicant grouping now? a grouping which cannot be expandable. What is essential prime implicant grouping? Which is having a speciality. What is that? At least one minimum which is not covered by, or one cube or one square which is not covered by other groupings. Then it is becoming essential prime implicant grouping. Then redundant, a non-essential prime implicant which is covering minterms which are covered by essential prime implicants only. Right? Right? That is the right definitions for PI and EPI and redundant. Understand correctly? Prime implicant grouping. Essential prime implicant. A prime implicant grouping which is covering at least one cube which is not covered by any other prime implicant groupings. Any other PI, prime implicant groupings. Prime implicant groupings. The prime implicant grouping which is covering at least one cube which is not covered by any other prime implicant groupings is essential. Redundant. What is redundant? A non-essential prime implicant which is covering cubes or minterms which are covered by EPIs only is called redundant. Get clarity. You must have 100% clarity. That's what my intention. Even though it looks like simple, just understand, write, or take a snapshot. And in this, let me make a note. If EPIs are covering all the minterms, then minimal expression is only EPIs. Then you must get it out. Do we get non-essentials also in minimal expression? Yes, we get. Yes, we get. When do we get that? We are going to discuss that. In this case, essentials are covering all the minterms. So minimal expression is only EPIs. But there is a possibility for getting non-essentials also in minimal expression. When and all we discussed. See, right. Observe this correctly and understand each and every statement. PI, EPI, redundant term. What is PI? Which cannot be expandable. A grouping which cannot be expandable is a prime implicant. What is EPI? It must be having a specialty. What is that? Compared to other prime implicant groupings, it must be covering at least one cube, which is not covered by any other prime implicant groupings. What about redundant? If a non-essential prime implicant is covering min terms which are covered by essential prime implicants only, then it is called redundant. To confirm it is redundant, the grouping must be covering min terms which are covered by essential only. Then it is called a redundant. Then it is called a redundant. Right. Now onwards, we need to find number of prime implicants, number of essential prime implicants, and minimal expression. Number of prime implicants, number of essential prime implicants. Manisha, what happened? Pranit, I have written the statements. These are the note you are expecting. Okay. In this, if you are observing final expression, what we have here? Only essential. This is becoming redundant. But means every time this non-essential will become redundant? May not be. Here, this non-essential, if you are observing, it is covering min terms which are covered by essentials only. This non-essential is covering two min terms. This is covering this one is already covered by this prime implicant. This is covered by this one. So these two are essentials are covering already these two min terms which are covered by this non-essential. So this non-essential is not covering anything extra, which is already covered by essentials only. So if it is covering, if a non-essential prime implicant is covering min terms which are covered by essentials only, then it becomes redundant. In such case, what happens here? If essential prime implicants are covering all the min terms, see, this is essential covering these two. This is essential covering these two. Then, if I consider these two, nothing is required because already functionally complete. Functionally complete. So this is essential, this is essential. These two essentials are covering all the min terms, then nothing is required to consider extra. That's what we mentioned. If essential prime implicants are covering all the min terms, then minimal expression is only essential prime implicants. Manisha. Right. Very good questions we have been getting based on number of prime implicants, number of essential prime implicants, especially. Focus on this in GATE and ESC. Frequently, we have been getting questions. Now onwards, always what is that here? Finding number of prime implicants, number of essential prime implicants, and minimal expression. So you need to find number of prime implicants, number of essential prime implicants, and minimal expression of the function. right? If this is the how many prime implicants, how many essential prime implicants, what is minimal expression? How many prime implicants, how many essential prime implicants, and what is the minimal expression? How many prime implicants, how many essential prime implicants, and what is the minimal expression? Right. Let us see grouping. Listen, just even though you are doing, just stop it there and just listen to me. Many are doing that mistakes, sir. I know what you are doing. So find groupings first, which cannot be expandable. Number of prime implicants is equals to number of possible groupings which cannot be expandable. One grouping, second grouping, third grouping, fourth grouping, fifth grouping. How many groupings possible? 5 groupings. How many prime implicants? 5 prime implicants. How many are essential in this? Be clear about that. See, going through each and every grouping, now I'm observing. In this grouping, special cube is there. Check it correctly. In this grouping, special cube is there. Essential. In this grouping, no special cube. Non-essential. In this grouping, no special cube. Non-essential. I know some of you might have considered this as a essential, which is wrong analysis. I did not say that whichever the terms are there in final are essential. I did not say. You are assuming. I'm not responsible. What I mentioned, after finding all prime implicant groupings, if you are observing a grouping is having a special cube, then it is essential. Otherwise, it is non-essential. Yes, this grouping is having a special cube, essential. This grouping is not having any special cube, non-essential. It is also not having any special cube, non-essential. It is also not having any special cube, non-essential. It is having a special cube. We are observing all after finding all possible groupings, all prime implicants, going through each and every grouping. If you are observing special cube is there, essential, otherwise non-essential. Yes, this is essential. This is also essential. Where are the other essentials? No. Only 2 essentials. Essential prime implicants is 2. Essential prime implicants is not 3. Essential prime implicants is 2. It is a time to change our way of analysis, our way of analyzing concepts. Be clear. You may be having your own assumptions. Come out of those assumptions. Follow what I mentioned in the statements. After finding all possible groupings, all prime implicant groupings, if you are observing a grouping is having special cube, then it is essential. If it is not having any special cube, then it is non-essential. So blindly we can follow. After finding 5 prime implicants, we are observing only 2 groupings are having special cubes. Sahil Singh, that's what I've been saying. So come out of your assumptions. What you are assuming? If it is there in final expression, it is essential. That is wrong assumption. Sahil Singh. The essential prime implicants is 2 only. What is essential prime implicant? A prime implicant grouping which is covering at least one cube, which is not covered by any other prime implicant grouping. In this we have a special cube. In this we have a special cube. Where is the special cube in this? No. Where is special cube in this? No. Where is special cube in this? No. Why are you saying that three essential prime implicants? Sagarika, please wait. Wait, Shubham Kumar, you are jumbling the concepts from one to another and so and so. Cool down, come down first. Follow correctly. What is the number of prime implicants? Number of possible groupings which cannot be expanded. What is the number of essential prime implicants? The number of groupings which are having special cubes. Don't get confused. Prime implicants, number of possible groupings which cannot be expandable. Essential prime implicants, the number of groupings which are having special cubes. How many groupings are having special cube? Only two. This is having special cube. This is having special cube. How many? Two. Now, after that, immediate step is what? Coverage of minterms by essentials. It is not covering all the minterms. Right? Now, let us write minimal expression. In the first essentials, A bar, B bar, C bar. Plus, what about this? A, B, C. These two are essential. But it is not complete expression. It is not complete expression. Then what should I do? I have to choose non-essentials also. See correctly. See, in this, essentials are not covering all the minterms. Stick to that essentiality, nothing but special cube must be there. These two only essentials. Yes, essentials are not covering all the minterms. Then we should go with the non-essentials. And again, these three non-essentials, which one should I consider? If I consider this one, it is covering only one. If I consider this one, it is covering only one. If I consider this one, two minterms will be covered. It is again optimized. Then what is it here? A bar B, D. A bar B, D. It is non-essential, but it is there in the minimal expression. A bar B, D is non-essential. Please don't consider it as essential. To be essential, it must be having a special cube. Is it having special cube? No. Right? Once again, suggesting again and again, don't go with your assumptions. Follow correctly. What is here? Here we have a bar, B bar, C bar, essential. A, B, C is essential. But essentials are not covering all the minterms. So we are observing we need to consider this non-essential optimally. Why? If I consider this one, it is covering only one. If I consider this one, it is covering both. If I consider this one, it is covering only one, which is not covered. To cover two minterms which are not covered by essential, this is the optimum one. So with minimum complexity, whichever is covering, that one will be considered in the minimal expression. So I would like to make a note here to give you clarity. To cover minterms which are not covered by EPIs, essential prime implicants, we need to consider non-EPIs in minimal expression with minimum complexity. With minimum complexity. To cover minterms which are not covered by essential prime implicants, we need to consider non-essential prime implicants in minimal expression with minimum complexity. Right? Please come out of your assumptions. If you are there only, I cannot help you. Please come out of your assumptions. Follow my concepts correctly. Prime implicant grouping cannot be expandable is prime implicant. Yeah, essential prime implicant. Special cube is there, essential, otherwise non-essential. Otherwise non-essential. Right? So, and after that, what we are observing, when essentials are not covering all the minterms, we have to consider non-essentials also in minimal expression. When essentials are not covering all the minterms, we need to consider non-essentials also in minimal expression. Right. Yeah, for your information, how many are redundant in that? If you are observing this non-essential, one by one, I'm addressing. This non-essential, is it covering minterms covered by essential only? No. Is it covering minterms which are covered by essentials only? No. This only essential. This only covered by essential. This is not a minterm from essential. So this is non-essential, but it cannot be named as a redundant. When can we say it is redundant? If a non-essential prime implicant is covering minterms which are covered by essential only, then we say perfectly it is redundant. Right? To say it is redundant, what we can say, it must be covering minterms which are covered by essentials only. Statements I have given, already explained, I am applying now. This grouping, if you are observing, is it covering minterms covered by essentials only? No. This is only minterm covered by essential. What about other minterm? It is not from essential. So it is not redundant. When can we say perfectly redundant? If it is covering minterms which are covered by essentials only, then we can confirm it is redundant. Now, what about this? It is not covering minterms which are covered by essential. What about this? It is also not covering all the minterms which are covered by essentials only. Yes, this is the minterm covered by essential, but this is the minterm which is not covered by essentials. Right? So there are no perfect redundant terms here. There are no perfect redundant groupings here. So it is a non-essential, but it is not a redundant. Such prime implicants are called selective prime implicants. SPI. If a non-essential prime implicant, if it is not a redundant, then it is called selective prime implicant. When can we say it is redundant? If it is covering minterms which are covered by essentials only. So, how do you define selective prime implicant? Neither redundant nor essential. Neither redundant nor essential. Then the prime implicant is called selective prime implicant. What is selective prime implicant? It is not a redundant. It is not a essential prime implicant. So selective prime implicant. Neither essential nor redundant. Then it is called selective prime. To say it is redundant, it must be covering minterms which are covered by essential only. But it is not essential, it is not a redundant. Then those prime implicants are called selective prime implicant. Neither essential nor redundant. Such prime implicants are called selective prime implicant. Neither essential nor redundant. Then it is called redundant. Sorry, then it is called selective prime implicant. So one by one, whatever we have discussed, go through that correctly. Don't get confusions. Please come out of those confusions. So redundant, We don't have redundancy here. To say it is redundant, what is it here? It must be covering midterms by essentials only. Then only we can say it is redundant, right? So, if you have any doubts, let me know your doubts. I will one by one. Yes. If anyone is having any doubts, please let me know. Yes, 3 SPIs. You guys sleep.
Sir, good evening, sir.
Yes, you guys sleep.
Sir, I have generally doubts, sir. I saw the previous gate paper, sir.
Okay.
In that, no negative marks questions is there, sir.
Yes, sir.
I checked the options, question answers, sir. Then two types of answers is there, sir. Like a 0.5 or a 0.25, like that answers is there, sir.
Okay.
In a exam, we have to click like 0.25 or 0.95. It is not coming, sir. How we have to write? I did not understand.
Please, Ma, once again, please explain. I did not understand your words. Please explain once again.
Okay, sir.
Scenario. In exam, there are questions which are not having negative mark.
బ్లాంక్స్ లాగా వస్తాయి కదా సార్. అయితే
Okay.
బ్లాంక్స్ లాగా వచ్చినప్పుడు కింద మాకు
So, numerical answer questions వచ్చినప్పుడు
న్యూమరికల్ ఆన్సర్స్ వచ్చినప్పుడు
అందులో మనకు ఒక రేంజ్ ఇస్తారమ్మా.
ఓకే.
నువ్వు నెంబర్ ఎంటర్ చేయాలి, అక్కడ క్లిక్ చేయడం కాదు, నెంబర్ ఎంటర్ చేయాలి నువ్వు.
ఎంటర్ చేయాలి కదా సార్. అదే ఆప్షన్స్ లో నేను ప్రీవియస్ గేట్ క్వశ్చన్ పేపర్స్ ఆన్సర్స్ లో చూసినప్పుడు 0.25 నుంచి 0.9 ఆర్ అని ఇట్లా ఇచ్చారు సార్.
అలా ఉన్నప్పుడు ఆ మధ్యలో నువ్వు ఏ వాల్యూ ఇచ్చినా సరిపోతుంది.
ఓకే.
మధ్యలో ఏ వాల్యూ ఇచ్చినా 0.25 0.26 ఎంత ఇచ్చినా పర్లేదు. ఆ రేంజ్ మొత్తంలో ఏ వాల్యూ ఇచ్చినా అది యాక్సెప్ట్ చేస్తాను.
ఓకే సార్.
న్యూమరికల్ ఆన్సర్ క్వశ్చన్స్ లో మనకు ఒక రేంజ్ కనుక ఫిక్స్ చేసి ఆల్రెడీ ఉంటే ఆ రేంజ్ లో నువ్వు ఏ నెంబర్ కొట్టినా కూడా కరెక్ట్ ఆన్సర్ వస్తుంది. దానికి నెగిటివ్ మార్కింగ్ లేదు. కరెక్ట్.
సార్ ఇప్పుడు దీంట్లో డిజిటల్ లో ఏమైనా క్వశ్చన్స్ ఉంటే అలా చెప్పండి సార్.
న్యూమరికల్ ఆన్సర్ క్వశ్చన్స్ ఆల్రెడీ చెప్తున్నా కదా, క్లాస్ రూమ్ ప్రాక్టీస్ క్వశ్చన్స్ లో ఉన్నాయి, చూసావు కదా, అవి ఇంక్లూడెడ్. రైట్.
థ్యాంక్ యూ సార్.
రైట్. ఆప్షన్స్ లేని క్వశ్చన్స్ కూడా ఇంక్లూడ్ చేసాం, చూడు ఒకసారి క్లాస్ రూమ్ ప్రాక్టీస్ క్వశ్చన్స్.
నిన్న ఒకటి ఇచ్చారు సార్.
x minus y.
సార్.
రైట్. చూడు ఒకసారి అలాంటివి ఉన్నాయి.
ఓకే సార్.
ఇంకా ఇస్తాను, అంటే నేను కొన్ని క్వశ్చన్స్ చేసి ఇస్తాను.
ఓకే సార్.
రైట్.
థ్యాంక్ యూ సార్.
థ్యాంక్ యూ. ఆశిష్.
Good evening, sir.
Very good evening, Ashish.
Sir, sir, I'm doing some previous year questions, sir. There is a
Okay.
concept, I don't know, a term shaft encoder. What's this shaft encoder and code of shaft encoder, sir?
One hot encoder. One hot encoder. Wait, we are in K-map only, right?
No, sir. I was solving from this simple operations. It's from logic gate chapter
Please,
1.
you can WhatsApp me such questions, please. If you are mentioning here, I cannot see the question also, right? Please WhatsApp me the questions. If possible, I'll reply in the WhatsApp. Otherwise, I'll discuss in the class if I need a board, if it is not possible to explain in WhatsApp. Let us utilize that, right?
Okay, sir.
Ashish.
Yes, sir.
Right. We do that.
Okay,
Please
sir.
send me the questions.
Okay, sir.
If you are not able to do that, please send me. If it is possible, I'll reply in the WhatsApp itself, or you can mail me, not a problem. But when you are mailing also, please mention that so and so batch and all. When you are sending questions also, please mention your batch and year also. Because some people have been sending from 3-4 years also.
Okay, sir.
Go on interrupting our regular duties. So please mention your batches, sir, when you are sending questions also. Please mention your name as well as your batch also. That will be useful. Or maybe getting quick reply depending on the batch. Right?
Okay, sir. Thank you, sir.
Thank you. Vamshi Krishna. Vamshi Krishna. Are you there? Please just wait. So, problem. Okay. Yes, sir. Sagarika.
Sir,
Yes, ma'am.
sir, in this last problem, we already know that only 3 groupings are enough for minimal equation, no, sir?
That's what you are doing in our graduation. But here, whenever it is asked number of prime implicants, we have to group all.
Okay.
There is a difference
But-
from regular exams and competitive exams. Competitive exams, they won't ask minimal expression only. When you're asking minimal expression only, just this one and this one, this one. Clearly, we can understand that.
Those are enough.
Yes.
Okay, sir.
But when it is asked number of prime implicants,
Then we should do all possible combinations.
in that essential, go with the observations.
Okay, sir. Thanks.
Thank you. Prasad. Prasad. Prasad, it is not audible. It is not audible, Prasad.
Hello.
Yes.
Sir, last question.
Last question. Is it?
దాంట్లో సార్ ఇప్పుడు SBI 3 సార్
SBI 3.
ఇప్పుడు SBI 3 అయినప్పుడు నాన్ SBI NEPI మొత్తం నాన్ ఎసెన్షియల్ ప్రైమ్ ఇంప్లిమెంట్స్ కూడా 3 కదా సార్?
SBI 3 నాన్ ఎసెన్షియల్ ప్రైమ్ ఇంప్లిమెంట్స్ 3. Redundant 0.
Redundant 0. ఇప్పుడు నాన్ ఎసెన్షియల్ ప్రైమ్ ఇంప్లిమెంట్ లో SBI redundant అనేది సబ్ గ్రూప్స్ కింద వస్తాయి సార్.
ఒకవేళ redundant ఉంటే కనుక అవి పోను మీద SBI అవుతాయి.
ఓకే సార్. ఓకే సార్. రైట్.
ఒకవేళ నాన్ ఎసెన్షియల్ ప్రైమ్ ఇంప్లిమెంట్స్ అన్ని ఫైండ్ అవుట్ చేసిన తర్వాత వాటిలో redundant ఉంటే కనుక అవి కాకుండా మీద SBI అవుతాయి.
ఓకే సార్. రైట్. థ్యాంక్ యూ సార్.
థ్యాంక్ యూ. ఓకే, భరత్. భరత్.
హలో సార్.
ఎస్ భరత్.
సార్ ఇక్కడ డౌట్ కదా సార్ నాది. కింద మీ బాటమ్ లో మీ ఫోటో రావాలి కదా సార్ ఇక్కడ.
ఏంటి
వీడియో
Screen లో,
వీడియోలో బాటమ్ లో మీ ఫోటో రావాలి సార్. అది 3 days నుంచి నాకు రావట్లేదు సార్ అసలు.
యాక్చువల్గా నా దగ్గర ఉంది, ఇగో అందరికి కనబడుతున్నాను.
కానీ నా దగ్గర అసలు 3 days నుంచి నేను అదే చెప్తున్నా సార్. చాట్ లో కూడా పెడుతున్నా కానీ అసలు నా దగ్గర మీ
అయితే
బాటమ్.
ఒకసారి జూమ్ అన్ఇన్స్టాల్ చేసి ఇన్స్టాల్ చేసి ఒకసారి
ఓకే
చూడు.
సార్, ఓకే సార్, ఓకే సార్.
నా దగ్గర అయితే ఉంది, అందరికైతే కనబడుతున్నా అనుకుంటున్నా.
నేను 3 days నుంచి మెసేజ్ చేస్తున్నా సార్, కానీ అది రావట్లేదు.
సరే
మీ
కనుక్కోండి,
bottom లో-
ఏమైనా ఇష్యూస్ ఉంటే ఒకసారి
ఓకే.
చూసుకోండి.
ఓకే సార్.
వర్షన్
Problem-
ఏమైనా పని చేయట్లేదా, లేకపోతే నీ మొబైల్లో
వాయిస్
data-
డేటా వైఫై ఉంది సార్, డేటా వైఫై ఉంది.
ఓకే, నీ
కాకపోతే
మొబైల్ స్పీడ్ కూడా ఒక రీజన్ ఉంటుంది. ఎందుకంటే ఇప్పుడు నేను ఒక ట్యాబ్ వాడుతున్నా అప్పుడెప్పుడు 10 years బ్యాక్ది, అది ఇప్పుడు నేను జూమ్ కాల్కి పనికి రావట్లేదు.
సార్ ఫోన్ బాగానే ఉంది సార్ నాది, మొన్న రీసెంట్ ఫోన్.
తప్పనట్లేదు నా పాసిబిలిటీస్ చెప్తున్నా. నేను
okay.
మా ఇంట్లో నేను ఫేస్ చేసి నేను చెప్తున్నా, నీకు టెన్షన్ పడకు, నేను ఏం అనట్లేదు, నేను
ఓకే సార్,
పాసిబిలిటీస్ చెప్తున్నాను. అంటే
Okay,
నేను ఆ ఓల్డ్ ట్యాబ్ లో ట్రై చేస్తే నాకు రాలా.
ఓకే ఓకే ఓకే
నేను చెప్తున్నాను, పాసిబిలిటీస్ చెప్తున్నాను.
ఓకే సార్.
జూమ్ లో వచ్చే ప్రాబ్లమ్స్ ఇవి ఈ మధ్య నేను ఫేస్ చేసిన.
అంటే స్టార్టింగ్ లో నాకు వచ్చింది సార్, స్టార్టింగ్ లా
అవునా?
మొన్న 3 days బ్యాక్ నుంచి నాకు రావట్లేదు.
అయితే జూమ్ ఏమైందో చూడు, ఒకసారి చూడు. సెట్టింగ్స్ అన్నా అంటారు, లేకపోతే ఏదైనా ఉంటున్నారు.
Okay, sir.
ఒక పని చేస్తావా,
సార్ చెప్పండి సార్.
ఫ్రెండ్ దగ్గర ఒక జూమ్ మీటింగ్ అరేంజ్ చేసుకొని మీరు ఒక ట్రై చేయండి.
ఓకే సార్, ఓకే సార్,
చిన్న ఒక జూమ్ మీటింగ్ నువ్వు క్రియేట్ చేసి ఫ్రెండ్ తో
Okay,
ఆ చేసి చూడు. ఒకవేళ అక్కడ వస్తే కనుక ప్రాబ్లం ఏంటో చూద్దాం.
ఓకే సార్, ఓకే సార్,
అదొక టెస్ట్ చేయొచ్చు.
ఓకే సార్, థ్యాంక్ యూ.
ఓకే భరత్,
రైట్ సార్, థ్యాంక్ యూ.
థ్యాంక్ యూ. శుభం.
Hello, sir.
Yes, Shubham. Tell me.
Sir, there is one note you have given that if EPIs are covering all the midterms, then minimal expression is the only EPI.
Yes, only API.
Sir, could you give an example like?
Here, same example, right? See, there only, as we observed here only, I have taken this. See, this is EPI covering 2 midterms, right? This is EPI covering 2 more midterms. Are there any midterms which are not covered by essential? This is one essential. This
No.
is second essential. Essential covering 2, essential covering 2. Total 4 midterms covered by 2 essentials. What else is required for me? If I already complete with respect to functionality, what is the need of considering other terms? No, that's what I mentioned. If EPIs are covering all the midterms, then minimal expression is only essential prime applicants.
Okay, sir. And sir, in question 1 of logic gates, what you have given, if like in question is given to find X, Y, and Z is given, and we have to
Boolean
find
expression for overflow.
So if we don't know the how do we get the idea of that?
We
at
should
one
know
time?
about overflow. That's compulsory.
Sir,
Overflow you must
overflow have you like covered, or you will be going to cover in
already
next one?
covered, right?
I thought there will
Overflow
be
in
more
number
detail.
systems we have covered.
I thought there will be more detail to it.
Not required. Much is not required. I'll take some examples, sir, for adding also. I'll give you some examples. Or at least for practice for you, I'll give you examples.
There is one condition that 0 plus 0 should be 1 for overflow, and 1 plus 1 should be 0.
Not like that. Not like that. You are adding X and Y. X and Y we are not adding. X and Y are sign bits of numbers which we are adding.
Yes, sir.
Read question correctly, please. When I'm
Yes, sir.
please, I'm requesting you, everyone, please read the question again and again. When you're not understanding the question, no use of this coaching, because I will not be there to help you in understanding the question. The first duty of student is understandability of the question. The first thing, please. Right way, if you are understanding the question, almost answer is done. If you are expecting someone should help in understanding the question, in exam, no one will be there. That only practice is most important for competitive exams. Understanding question, if you have done, nothing is there in the question. Mostly with the coaching, you can do all the questions. The only thing is that people are not able to understand what is given, what they are asking. So people have been assuming themselves with the earlier questions. No, that is not the correct way. Don't assume. Understand what is exactly given, please. Not only you, I'm saying everyone, suggesting everyone. The first duty is understanding question in right way. There, 75 or 80% of the question already done. 20% concept is required to answer the question. So where people are failing is understanding question. Yes. Yes, sure. Try that. I'm there to help you. High level, right?
Okay, sir. Thank you, sir.
Manisha.
Good evening, sir.
Good evening. Very good evening.
Sir, in last slide, I have
Okay.
a-
Last slide.
sir, in that once explain what are non-essential prime implicants.
If your grouping is not having special group, non-essential. See, in this grouping, is it having any special group?
No, sir.
In this grouping, is it having any special group?
Sir, it's not audible, sir. Your voice is not
In
audible.
this grouping, do we have any special cube covered by this only?
No, sir.
Then non-essential. What about
Yes.
this? No special cube.
Yes, sir.
What about this? Special cube is there. This is special cube.
Yes,
So
sir.
it is essential. Huh?
Yes.
Right? This is essential. This is also essential. Only two essentials.
Sir,
Understanding? Yes.
yes, sir. Sir, then what's the difference between special prime implicants and non-essential prime implicants?
Essential is having special cube. If special cube is not there, non-essentials.
Sir, not no, sir.
Selective prime implicant means if you are not able to confirm a non-essential is redundant. If you are not able to confirm a non-essential is redundant, when can we say it is redundant? If it is covering midterms covered by essential only,
Yes, sir.
then we say it is redundant. If it is not a redundant, non-essential, but it is not a redundant, then it is selective prime implicant.
Sir means now special prime implicant and non-essential prime
Special
implicant.
selective prime implicant. SPI is selective prime implicants.
Sorry, selective and non-essential prime implicants are same, sir.
So it may be redundant, right? Neither essential nor redundant. Neither essential nor essential, correct? But it should not be a redundant.
Sir, in previous one, you drawn one Karnaugh map, na, sir.
Yes.
Sir,
Yes.
open that one.
I'm going to that. Okay. In this.
Sir, here the redundant one is there, na, sir. That will be a non-essential prime implicant.
It is non-essential, but it is not selective prime implicant
Okay.
because it is redundant,
Okay, sir.
right? When can we say it is selective prime implicant? It should not be a redundant. Non-essential, but it should not be a redundant.
Sir, but non-essential prime implicant should always be a like anything, like it can satisfy anything, but it should not be an essential prime implicant. That's it, na, sir.
It should not be essential. It should not be having a special cube. It is non-essential.
And there is no other restrictions for that.
No. If it is not having special cube, it is non-essential. In that, again, we are confirming whether it is redundant or not. If it is not a redundant, then it is selective prime implicant.
Okay.
Right?
Sir, if we have a Boolean expression like f of a, it is given in this slide, na, sir. Now in this for this Boolean expression, how many literals are there,
Don't go
sir?
with this method. Don't go with this method. There will be confusions because how much we need to minimize, we don't know.
Yes, sir.
Right? Whether we have done correctly or not, we don't know. That is the reason all this to understand terminology. Then all this is to answer the questions.
Sir, not like that, sir. I have a doubt. Like we have to, if they ask find how many literals are there in a Boolean expression.
That I will
Then-
discuss in case. Yes, literal counter,
Yes, sir.
variables counter. I will discuss that questions. We
Okay.
have in classroom practice questions also. I will discuss.
Okay.
Right, I will discuss. Right. Done, ma? Manisha.
Sir, thank you, sir.
Thank you. Bharat Chandra. Yes, Bharat.
sir.
Yes, Bharat.
Sir, I have a little bit about doubt about redundant and self-prime
Okay.
implicant.
Okay. What is the doubt?
Sir, so in the next slide, so here we will find the non-essential prime implicants first, no, sir. For to find the redundancy, so first we will find non-essential prime implicants.
Yes.
So when I found that it is A bar C bar D, A bar BD, and BCD.
Or,
So, sir,
or non-essentials.
non-essential, sir.
Yes.
So the redundancy means that these prime implicants which are covering min terms which are covered by
I understood your doubt. I understood your doubt. Listen. See, it is non-essential. No doubt in that, right?
yes, sir.
It is non-essential. Any doubt?
Yeah, no, yes, sir. No doubt.
It is non-essential.
Yes,
It
sir.
is also non-essential. Correct?
Yes, sir.
These three are non-essential.
Yes, sir.
So going through each and every non-essential, if you are observing this, is it covering min terms only covered by essentials?
So that step I am not understanding.
See, in this non-essential, we have two min terms, right?
Yes, sir. Two min terms.
One is covered by essential. Second one is not covered by essential.
Yes, sir.
If this is also covered by essential, then would have said that it is redundant.
Okay, sir.
So all the min terms of this non-essential prime implicants are covered by essentials, then it becomes redundant. If you are observing this, there are two min terms. One is covered by essential. Second one is not covered by essential. If this is also covered by essential, would have said that it is redundant. Right? See, in the previous example, this is non-essential. Right? This min term covered by essential, this min term covered by essential. All the min terms of this grouping covered by essentials. Are you understanding?
Yes, sir. I am getting it. So
In this redundant or zero,
redundancy is zero, sir.
selective prime implicants are 3.
Yes. That's what then how it is neither
Essential.
not redundant.
First thing is it is essential. It is essential. Remaining are non-essential. In this non-essential, you need to exclude redundant terms.
So if we get any one of this term is
If a non-essential is not a redundant, then it becomes selective prime implicant.
okay, sir. If any of the three terms, any one term is not a it is a redundant means then remaining two terms will be a selective prime implicant, right?
Obviously, obviously. If one is redundant, remaining two will be selective.
Yeah, okay, sir.
Okay.
Thank you, sir.
Venkata Brahma Reddy.
సార్
Sir,
హలో సార్
yes, tell me.
ఏం లేదు సార్ అదే సార్ ఇప్పుడు ఫస్ట్ మీరు కే మ్యాప్ చెప్పారు కదా సార్
అవును.
సార్ నోట్స్ రాయాలంటే అది మీరు ఫస్ట్ తర్వాత వీడికి ఫస్ట్ ఎసెన్షియల్ ప్రైమ్ ఇంప్లికెంట్స్ రిడక్టెంట్ టర్మ్స్ ఇలా డెఫినేషన్ చెప్పారు కదా సార్ ఇది నోట్స్ ఎలా ప్రిపేర్ చేసుకోవాలి సార్ మనం అసలు
ఏమక్కర్లేదు, మన కరెక్ట్ గా ఫాలో అవ్వు. ఎగ్జాంపుల్ చెప్తాను.
ఓకే సార్ మీరు చెప్తున్న అర్థమవుతుంది సార్. అది కాదు దాంట్లో సార్ ఇప్పుడు తర్వాత ఒకసారి రిఫర్ చేసుకోవాలన్నా కానీ మనం తర్వాత ఏదైనా ఇంటర్వ్యూ ప్రిపేర్ అవునా కానీ
ఏమన్నా కావాలంటే నన్ను అడుగు, నేను చెప్తాను.
అలాగే సార్ అందుకని ఒకసారి సార్ ఇప్పుడు లాస్ట్ దాంట్లో 3 ప్రైమ్ న్యూమరికల్స్ ఏ బార్ బిడి ఏ బి బార్ సి బిసిడి కదా సార్?
ఇవి ఏంటి?
ఎసెన్షియల్ సెలెక్టివ్ ప్రైమ్ న్యూమరికల్స్ సార్.
సెలెక్టివ్
SPS.
వచ్చేసి ఇది సెలెక్టివ్ అవుతుంది,
అదే సార్.
అవుతుంది, ఇది సెలెక్టివ్ అవుతుంది.
ఏ బార్ బిడి
ఏ బార్
బిడి
సి బార్ డి, ఏ బార్ సి బార్ డి, ఏ బార్ బిడి, నెక్స్ట్ బిసిడి.
ఎస్ సార్, బిసిడి రైట్.
మూడు సెలెక్టివ్ ప్రైమ్.
ఓకే థ్యాంక్ యూ సార్.
థ్యాంక్ యూ. Any more doubts? Any more doubts? Mangesh. Yes, Mangesh.
Sir, can you show in the example any example SPI, sir?
I will take more and more examples. It is not done. I'm going to discuss tomorrow. Not next class.
Okay.
Right? I'll discuss. You will get 100% clarity, no doubt.
Okay, sir.
Okay.
Thank you.
Sajjan Singh.
Good evening, sir.
Very good evening, Sajjan.
Sir, in that 7th question, majority gate, can we solve using Boolean algebra?
It becomes very complex because we are applying in that. So first is what? AB plus BC plus AC whole bar,
Yes, sir.
comma, right? AB plus BC bar plus AC bar,
Yes, sir.
right? Comma C. Again, you need to apply that. So first is PQR. If I say PQ plus QR plus PR, then simplifying. Then we are getting an expression. Then we need to simplify that. Then we can do K-map.
Okay.
Right? K-map. We can do.
Okay.
Okay.
Thank you.
Anything else? Sajjan. Okay. Abhijit.
Good evening, sir.
Very good evening, Abhijit.
Sir, if there is one more midterm at 10 in last example, then there will be a extra 1 PI or 2 PI at
Here you are
place
saying
of 10.
8,
I am
9, 10.
10.
One more prime implicant. The essential will be 2 only.
One more prime implicant.
You are
Can the
grouping like
diagonally
this. If you are
can
grouping
the
like
diagonally
this,
opposite
you are saying that
diagonally opposite cannot be grouped?
Which one? These two? This with
0
this?
and 10. 0 and 10.
No. In cross, we
Can't
don't
be.
have, first of all, because they must be adjacent. In cross, is there any sharing of edge? Please don't blame me.
Okay. Sorry. Got it.
Sharing of edge adjacent can be grouped. You are in cross means there is no possibility for sharing of edge, right? They are not adjacent.
Yes.
They are not differing in 1 bit. 0, 0, 0, 0. 10 is what? 1, 0, 1, 0. 2 bit difference is there.
Then there will be only 1 PI extra, no?
1 PI extra. Essential 2 only again, Mal.
Essential 2. Okay.
Essential 2 only. Prime implicant 1 will be increased.
Yes, sir. Thank you.
Manisha.
Sir, I don't have any doubts, sir, but I need for practice exclusively the topics which you have said, na sir. I need some more sir.
Questions I'll give you. I'll prepare the questions, I'll give you.
Okay, sir. In other books we are getting I'm getting combined topics, like we have to analyze 2 topics at a time so that it will not be relevant to the class.
First topic wise you need to get familiarity.
Yeah.
Right? So
Yes, sir.
next obviously you have to do that combination of multiple topics. You have to solve. Later you need to solve. First go through these.
Sir, not like that, sir. means the topics which you have covered, I want to do only those, sir. But other gate exams and all
Topic-wise questions you are expecting, like
sir.
topic-wise questions.
Yes, sir.
I
Like in that topic, the things which you covered till now, we can do. Like I can do, sir. But
Okay.
the extra topics
Okay.
which you didn't had covered, all those we can't, sir.
Okay.
So
Okay. So next topics, you are not able to because you are not able to eliminate those questions, right?
yes, sir.
Okay. You may be feeling low by seeing that question. Oh, I'm not understanding.
Yes, sir.
You must be in a position to differentiate that question, right? If it is add or something else, it is not done.
Sir, not like that, sir. Normally, if any, like any other.
Okay. We'll talk it later. Okay. Understood. I understood. I'll give you topic-wise questions, right? Happy?
Yes, sir.
Okay.
Okay, sir.
Okay. Yeah, Rajita, non-essential prime implicant is not a redundant, is a selective prime implicant. 100%. 100%. Neither essential nor redundant. It is not a essential, not a redundant. Then it is called selective prime implicant. Okay. Avinash.
Hello, sir.
Yes, Avinash.
Sir, I had a doubt that in K map, the number we are writing 0, 1 and 1, 0. If we exchange both, so can we write the K map according to that or not?
What you are saying? 0, 1?
Like number we are writing 0, 0, 0, 1, 1, 1, 1, 0.
Yes.
What if we write 0, 0, 1, 0, 1, 1 and 0, 1?
You can write, but the combination also you need to write that in order only. No problem.
Yes, sir.
No problem.
So it
Reverse
doesn't
gray
change
order you are saying.
any other.
No problem. But combination you need to understand correctly. Where you are marking midterms and maxterms also you need to understand correctly. Then you will get correct answer.
And so before you were saying that it's forward and backward, something like that.
Forward gray and backward gray.
Okay,
0, 0, 0, 1, 1, 1, 1, 0 back to 0, 0 is forward.
Okay.
Right?
Okay.
Yes.
Thank you.
Thank you.
Forward करे backward भी बोल रहे.
Yeah, Bhaskar. 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 Are you there?
Good evening, sir. Hello.
Yes.
Sir, doubt time లేదు sir, but videos upload చేయలేదు sir.
చెప్తే నేను చేస్తాను.
అంటే నేను స్టార్టింగ్ 3 days అవి అటెండ్ కాలేదు సార్, రిజిస్టర్ కాలేదు.
ఓకే.
అవి వీడియోస్ కావాలి సార్.
అదే ఒకవేళ ఛాన్స్ ఉంటే వాళ్ళు ఏమన్నా రిస్ట్రిక్షన్ చెప్పలేను.
ఓకే సార్.
అయితే వాళ్ళకి అవైలబుల్ ఉన్నాయి. ఏమన్నా రీజన్ ఉందేమో తెలియదు. ఒకవేళ ఉంటే కనుక కనుక్కొని చెప్తాను. ఒకవేళ లేకపోతే కనుక నెక్స్ట్ ఏదో బ్యాచ్ స్టార్ట్ అవుతుంది కదా అందులో అటెండ్ అవుతుంది.
ఓకే ఓకే, థ్యాంక్ యూ సార్.
Okay then, see you on Monday.